Good morning, good morning, good morning. After a long marathon till midnight, back you are. It shows that you have that in you to crack J 2026. Welcome aboard. This is your Captain Shreyas on the number one J English channel, which is Vedantu J English. And this is your Captain Shreyas. I've been teaching, guiding, mentoring kids just like you for the past 13 plus years, making sure no matter what stage you are in, you improve, you get your seat which you deserve. So it's time that we fire ourselves up because this is the end. This is the end game. We are close, but not yet there. And in this time, whatever we do, even one minute will matter. So I have got the best of the best 69 questions for all of you from three very big important chapters: ray optics and optical instruments. Then we'll go to wave optics, light waves basically, and then we will move on to electromagnetic waves. So all the three things in this particular session. The session might be around 3 hours, I feel. Yeah, not more than that. So around 3 hours. Okay. So ready to start with ray optics, and have you guys marked your attendance for this particular class? And if you have not done that yet, do that right now. Okay. One second. Session might be around Bro, I want to turn off the volume. Yeah. I can't have this. One second. Okay, one second. Okay, perfect. Yeah, smash the like button right there. And by the way, if you see in the description box, there is this link, ask Ved any doubts. So even during the class or even after the class, you can ask Ved doubts. Smart notes will be created, quizzes will be created after the class, and the entire PDF of today's lecture will be available there. So when you open that, you will see these three things. You can see the comments, you can ask doubts to our AI, and the description will also have the lecture notes after the session is over by tomorrow. By Monday, it will come up. Okay. So that's Ved for all of you guys working tirelessly day in, day out. Ready, guys? Good morning, and already like the session. I'm not confident in optics, so hopefully today's session will help you out. Harni, welcome. Hi, Ibu. Sir, approximately session duration, I told around 3 hours. Okay, Vikrant, hi. Welcome, Yazin. Hi, Nika. Yep. Will you teach, sir? No, I will not teach wave optics. If you want the wave optics class, I have taught it in detail right over here. I had conducted a special marathon for it. See, alternating current I have taught. Electromagnetic waves I have taught almost 3 hours. Wave optics almost 5-6 hours. So you can watch these classes. I have taught detailed theory of every single concept in that. So watch them, because if I do it in a hurry, you might feel a bit lost. So I have kept this exclusively for problem solving so that you can apply those concepts. Let's begin. The first question coming up on your screen, guys. Ready? Yeah, good morning, Aditya. All right, all right. Harshad, hi, Lewis, good morning, good morning. To get images of a single object, the angle between the two plane mirrors should be what exactly? Now there is this formula which is nothing but 360 divided by theta minus 1, and that gives you the number of images. In this case, the number of images is basically 3. So if you take that 1 on the other side, it will become 3 plus 1 is nothing but 360 divided by theta, which is nothing but 4. So hence I can just take theta on the top. 360 is as it is. 3 plus 1, which is 4, I will bring it below. So theta will be nothing but 90 degrees. So the correct answer for this is option D. Yeah. No, not C, guys. I don't know why you guys say C. It is option D. Okay. Keep this in mind. So this is the formula which you will use. Now keep in mind that this formula works, provided when 360 by theta, what is whatever that number that you get over here, from that you should get an, what do you say, an odd number. Okay, but if you are getting an even number, then you will have to subtract 1 from it. Meaning, for example, when I do 360 divided by 90 degrees, 360 by 90 degrees, the number is 4. Never keep the number even. So the moment it becomes even, You have to turn it into odd number by subtracting 1, and hence this is the answer. By chance, say for example, it was 360 divided by, let's say, 120 degrees, Chumma I'm saying, then the answer will be just 3. Then don't have to do anything, just keep it as it is, don't have to touch it at all. Now, by the way, there is one catch in this particular problem. When you can use actually any of these formulas, and you will see that answer will be anyways 3 images. So actually this question can have two answers, either 90 degrees or even 120 degrees. But 120 degrees is not there in the options. That's why I'm going with 90. But if 120 was there in the option, then it would be a tricky question, because then you have to think that where and all can I get that number 3 from? Either 360 by 90, whichever number you get 4, because it is even, you convert it into odd by subtracting 1. But if you divide by 120, already it is odd, you don't have to do anything, just keep that number as it is. So that is the logic behind these kind of questions. Okay, clear? So there are two options which are possible, but 120 degrees is not there, hence we are not marking. But sir, what to do if 120 and 90 both are there? Then either it will be bonus question, or there will be an option which says option A and B are correct, something like that. So then you can mark two answers. All right. Let's move ahead to the next question coming up on your screen. Here it is. The image of an object approaching a convex mirror of radius of curvature 20 meter is observed to move from this point to this point in 30 seconds. Question is, what is the speed of the object? They have asked what is the speed of the object, not the speed of the image. In fact, image locations are given. Image locations are basically already given. Okay. So I just mentioned, Jani-san, okay, what to do in that case if both options are there. First things first, what is the focal length? And everything is in meters, so I will not convert it into centimeters. Let it remain. We know R is basically 2 times of focal length, which means the focal length will be radius of curvature, which is 20, divided by the number 2. Since it's a convex mirror, the focal length has to be positive, so it is nothing but plus 10 meters. All right. Now, let's go one by one. Let's use our mirror formula 2 times. First is 1 by V plus 1 by U is equal to 1 by F. Focal length is nothing but 10. When you see the image of an object is moving from this point. So this is the first scenario. Earlier the image is here, then it is going here. So this is the image distance 1 by V, that will be positive 25 by 3. And I do not know what that object distance is, so I'll just put U1 over here. Second time, this is the image distance. So 1 divided by image distance, which is V, plus 1 by object distance is still going to be 1 by the focal length. From this, I will get two locations of that object. So what really happened over here is that you have this convex mirror. This is your principal axis. Your object was over here first, then your object has moved over here next. It has gone like this. Automatically, your image will also go from this position to, let's say, some position over here. So the image distances were given to me, this and this. And remember, image side is going to be positive, this side is going to be negative. So if the image moved, how much did the object move by? From that, you can calculate the speed of the object. Okay. Now solve this and tell me what is the value of u1 and u2 you are getting. Just move this around here. So therefore, 1 by u1 will be 1 by 10 minus 3 goes on the top divided by 25. Therefore, 1 by u1 will be LCM is nothing but 50. So this will go 5 times. This will go just 2 times. So 3 2s are 6. So this will just become negative 1 by 50. So therefore, object distance 1 is negative 50 meters. Just check if object 1 distance you have got it as negative 50 meters, everyone. Then for the next one, try to do the same thing, guys, and tell me what is the answer that you are getting. 1 divided by u2 is nothing but 1 divided by 10 minus 7 divided by 50. You can see that the LCM is just 50, guys, plain and simple. This goes 5 times, this goes 1 time, so that is 7. 5 minus 7 is negative 2. So negative 2 by 50, which is negative 1 by 25. So therefore, object distance in the second case is negative 25 meters. So from this, we can really figure out how much has the object moved. So the object has moved delta U from 50 to 25. So take the modulus of it. So just take the modulus of it. The real movement is 50 minus 25, which is basically 25 meters, which is basically 25 meters. So the velocity of that object on an average will be the distance that it has traveled divided by the time. How much time? 30 seconds. So 25 by 30, that will be meters per second. You need to convert it into kilometers per hour. Yes, you need to convert it into kilometers per hour by multiplying it by what? How will you convert meters per second into kilometers per hour? Yeah, you'll have to multiply it by 18 by 5. Yeah, not multiplied by 5 by 18, multiplied by 18 divided by 5 to convert it into kilometers per hour. How much is the answer coming out to be? How much is the answer coming out to be, guys? Come on. Quickly tell me the answer in the chat box right away, right now. So 5 by 6 meters per second. Yes, very good, very good. The answer comes out to be 3 kilometers per hour. Amazing. So that means I should mark D for IIT Delhi, which is absolutely the right answer. So good question, because conversion of units is involved. Second thing, it's not the usual units. Instead of centimeters, it's in meters. You had to also calculate the focal length. You have to use mirror formula 2 times with proper sign convention, then figure out the distance and divide it by time to calculate the speed. So overall, a question which will definitely consume 1 to 2 minutes of your time, not less than that. Yeah? Okay. Let's move now to the next question coming up on your screen. The angle of incidence is found to be double, twice the angle of refraction when the ray of light passes from vacuum through some medium whose refractive index is given. Angle of incidence will be in which of these trigonometric forms? Sine inverse, basically, cos inverse, whatever. Okay, the angle of incidence. Now, clearly, it is mentioned in this question. The angle of incidence is double of the angle of refraction during this medium change. So, 2 times of r. So, if I use Snell's law definition, refractive index is sine of angle of incidence divided by sine of angle of refraction. It kind of makes sense. I is nothing but double of r. So I can just put sine of 2r. That is one way about it. But I want to find I. So rather I would substitute r for it. I would rather substitute r for it, because r will be nothing but I divided by 2. So I will write it as sine of I divided by 2. Why did I do this? Because I want to find I don't want to find r as per the question. Now, what can I do with this? This is nothing but double angle formula, guys. It's not looking like that, but we can do it. Sine I is sine of 2 times of I by 2, because I is double of half of I. So I can write it as 2 times sine of I by 2 into nothing but cos of nothing but I by 2. 2 sine theta cos theta is nothing but sine 2 theta. So this is sine I by 2, which is going to be cancelled. So this will be nothing but 2 times of cos I divided by 2. That is your refractive index. Shift that 2 on the other side. So therefore, cos of I by 2 will be mu divided by 2. Now, therefore, I by 2 will be equal to cos inverse of mu by 2, and 2 goes on the top. So therefore, I will be equal to 2 times of cos inverse of mu by 2. 2 times of cos inverse of mu by 2, that is B for your IT Bombay. Excellent. Very good, Sabrinathan Lewis. Yes, Pavi. Very good, Janani Chandru. Amazing. Very nice question. Who asked this? KL Rishi. Very good. Sir, why did we not use velocity formula in the previous question? Very good. Can somebody answer this in the chat box? Because I'll tell you, the velocity formula which we have, velocity of the image, velocity, what has happened? Velocity of image upon velocity of object is negative v square by u square, is not applicable here. It is not applicable here because you can easily find velocity of the image from here. I know v, I know u, and I can substitute and get velocity of object. The problem is, which value of v will you substitute? This or this? Number one. Number two, this formula is only applicable when you want to find instantaneous velocity, not average. And this is a decent distance. So for such decent distances, you would have no other choice but to calculate separate objects and image distances and then find the displacement and then divide it by time. This is not applicable because this will only work only for instantaneous values or very small displacements. Very small displacements. Got it? Very good. Amazing. No, it's not about not a point object. Point object also, it is lengthy object also, it will work. That lengthy object will move. But how much it moved matters. It should move very less. This is not very less. This is decent only. So that's why we cannot use it. Good, you asked that. And that is the whole purpose of this session, guys. Because many times you don't know when a formula is applicable, when it is not, and how to use it, when not to use it. Like even in the first question I told you, see boss, you have the answer as 3 using both the formulas. It can be 360 by 90 degrees also, 360 by 120 also gives you 3. But in the option 90 was there. So that is the whole purpose of this session, because if I teach you theory, you will be like, ha sir, I understood. You will watch 100 theory classes, you will feel like you know everything. But the only time when you understand what you don't know or what you know is when you solve problems. That's why for physics and maths specifically, you need to do it via problems. Yeah. Image velocity is not constant. That is also possible. That's why it's a big distance. So in that big distance, anything can happen. It could be a variable speed. So what we find is average. Correct. Light travels a distance of x in time t1 in air and 10x in time t2 in another denser medium. What is the critical angle for this medium? Critical angle, let's try to recollect. Sine of our critical angle is 1 by the refractive index, and refractive index of any medium is nothing but, what is the refractive index formula? Speed of light in air upon speed of light in that medium. Basically C divided by velocity in that medium. This is speed in air or in vacuum, you can say, upon Vm, which is as good as saying it is Vm divided by speed of light in air. Okay. Now what is the speed in vacuum? For vacuum, sorry, not vacuum, medium. Denser medium, it has traveled this much distance in this much time. So speed is distance by time. So I can say the numerator of this is nothing but 10x divided by whatever time it has taken. Speed in air, it has traveled x distance in time t1 in air. So speed is distance by time again. So it is x divided by t1 over here. As you can see, x and x will cancel. T1 will go on the top. So 10 times of T1 divided by T2. So 10 T1 divided by T2 is sine. Therefore, critical angle will be sine inverse of 10 times of T1 divided by T2. 10 times of T1 divided by T2 and sine inverse of it, which is option A for IIT Abu Dhabi. Amazing. Very good, Harni. No, it's not B. Yes, Pavi. Awesome. Yes, Granol. Sabrinath. Yes, Gurugud. So make as many mistakes as possible. Even if you give all the answers wrong, I will be very happy because I will feel that I have saved so many marks just from today's session. Because just imagine you making those mistakes in the real exam versus making it here and correcting it. So watch every single question, solve every single question, because don't take anything lightly. Even the easiest question will suck your marks, and then you'll realize actually I was thinking about J in a completely wrong way. Because people think J means difficult questions. Yes, it is difficult questions if you want more than 99.5 percentile or 99.1 percentile. But if you want 98, 97, 99 percentile, it is easy to medium questions and a couple of here and there hard questions which you need to solve. Moving on to the next one. Okay, ready for it? Yes, my dear warriors, keep up the josh and do not forget to like this video right away, right now, in case you are forgotten. Just reminding you, yeah, that is your Guru Dakshina which you need to give me. I'm not asking for 100 rupees or 1000 rupees or 1 lakh rupees. I'm just doing it all for free. Sunday, it is a holiday. I last class was on a Christmas. So every holiday I am here with you. Okay, sacrificing. So at least that much you can do. A ray of light traveling through rare medium is incident at a very small angle I on a glass slab, and after refraction the velocity is reduced by 20%. What's the angle of deviation? Okay, so for deviation we need refracted angle. Without that we cannot do it. But one thing is given, the speed of light has reduced by 20%. So if my original speed was c, it has reduced by 20%, that means 0.2 c. So the final speed will be zero point 0.8 times of c, which I can obviously write it as 8 by 10 or nothing but 4 by 5 times of c. If you move this around a little bit, then we can also say we can get the refractive index, because that's what we'll need. So refractive index is speed of light in vacuum upon speed of light in that medium. For that medium, it is 4 by 5 times of c. Cc will cancel, so it will become 5 divided by 4. So this is the refractive index, which is nothing but 1.25. Okay. Once I get the refractive index, I think we can find the refracted angle. So using Snell's law, mu is equal to sine of I divided by sine of R. Mu is nothing but 1.25. 1.25. Now clearly given very small angle, so we can use small angle approximation and we can say I divided by R over here. Therefore I is nothing but 1.25 times of R, or rather R is equal to, we need the refracted angle. So refracted angle is I divided by 1.25. 1.25 was 5 by 4, so it will just become 5 by 4 times of I. So this is the angle of refraction. Why did I do this? This is only because of small angle approximation. Small angle approximation, where we know that sine of theta is approximately theta. Sine theta is approximately theta. Okay, everybody till this point absolutely clear? Now what do we do next? Think. Refracted angle I know. Question is, what is the angle of deviation? Angle of deviation is modulus of I minus R in case of refraction. For mirrors, it is 180 minus 2I. So be careful. So now I is I only, R is nothing but 4 by 5 times of I. So I don't need the modulus because this is bigger than this. So it's a positive value. So it will be just I divided by 5. So that's your deviation. I by 5, which is option A, obviously. Okay, so it's a very good question because it involves the relationship of speeds with refractive index formula. Concept that you have to first figure out what is the new speed because it reduced by 20%. Then you using Snell's law to figure out refracted angle, and finally deviation. And many kids make a mistake here, they write 180 minus 2i. And also a small mathematical concept of trigonometric approximation. Sin theta, tan theta, theta are equal for small angles in radians, and cos is numerically close to 1. Yeah. Okay. No, Lokesh, I'm not teaching concepts, bro. I've already taught ray optics in detail. If you have not watched that class, please check it over here. Okay, it's there in our amazing playlist. You can just go to view full playlist and you can see ray optics right over here. See, ray optics has been taught in detail. You can watch these classes. This will clear all your concepts. Okay, and these are this year's classes, fresh classes, proper in detail from the scratch till proper problem solving and PYQs. Okay, everything is there. Watch that. Okay, moving on to the next question on your screen. Here it is. There is a glass slab of thickness which is placed on a paper on which an ink dot is marked. By how much distance will that ink dot appear to be raised if the refractive index of glass is given? Now, there is a direct formula for these kind of questions. And what is that formula, guys? What's that formula? The formula is the shift which happens is the thickness of that slab into 1 minus 1 divided by mu. Directly you can use this and you will get the answer. So thickness is how much? 4.8, and refractive index is 1.5, which is nothing but 3 by 2. So it will become 2 by 3, and 1 minus 2 by 3 is 1 by 3, and 4.8 divided by 3 is nothing but 1.6 centimeters. So this is the amount by which it will shift. This would be real, this would be apparent, and this is basically how much you are shifting it by, the delta x, which is 1.6 centimeters. Option A, of course. Okay, direct formula, guys, nothing else which you need to use. Let's go to the next question on your screen. Three immiscible transparent liquids with different refractive indices are arranged one above the other. The depths of the liquids are also given. The apparent vessel depth is how much? So in these sort of questions, what happens is you might be given multiple liquids, and each liquid having its own thickness or depth, T1, T2, T3, H1, H2, H3, whatever you want to call it. Refractive index mu1, mu2, mu3. So what happens is there is an observer who sees things from the top. This was the real base. This was the real base. What happens is the base appears to be shifted. So this becomes the apparent. This becomes the apparent. So this was the real depth versus this is the apparent depth. So what is that apparent depth? So the apparent depth is, simply put, each each depth you take and divide it by refractive index and add them. T1 by mu1, T2 by mu2 plus T3 by mu3, and so on and so forth. It's as simple as that. Usually you see only this formula. Apparent depth is real by refractive index. But if more layers are there, keep on adding it, you will get the total apparent depth. That's all. Okay. So you remember this formula? Apparent depth is real depth by refractive index. Just keep on adding it. So what is T1, T2 and T3? It is 3, then 4, and then 6. What are those refractive indices? 3 by 2, 4 by 3, and 6 by 5. Wow, so nice. All the numbers are getting cancelled. So I'm left with 2 plus 3 plus 5. 2 plus 3 is 5. 5 plus 5 is 10 centimeters. So 10 centimeters, D option for ID Delhi is the right answer. Very good. Yeah. These are just not going to be enough, man. We will have to do more problem solving sessions. How can I say it is enough? Not possible. We are going to do more problem solving sessions. January month, more marathons, mock tests, so many more problems we are going to solve. This is not going to be enough. We have to do this plus more. We are not going to stop here. Okay? So never say this is enough, because no matter how much you do, there will be always one thing which you can learn from some problem. Okay? Don't be satisfied, because I am expecting the JEE paper to be little bit on the tougher side this time. Okay? Yeah, the physics paper specifically. That's what my hint, my gut feeling, my intuition is saying. It will not be very difficult, but I feel it will be harder than last year, is what I am guessing. And that's what we need to be prepared for. Okay, we'll solve all the models. Remember, no matter what happens, be it physics, chemistry, or maths, in maths, the proportion of easy questions is less. In physics, the proportion of easy to average questions is comparatively very high. In chemistry, it is even higher. So, keeping in mind that you will anyways get 4 marks for every question you solve, irrespective of the subject, it is strategically wise that you solve more of chemistry easy questions than of physics and then of mathematics, unless they decide to change the order, which is highly unlikely. And then, based on your strengths, think which particular subject you can score marks in. Okay. At the bottom of a tank, having liquid with refractive index, okay, M, refractive index of that liquid is M. There is a plane mirror, a small object M is situated at the height mirror with refractive index combined. Object M is at a height D above the mirror. The object M and its image in the mirror are visible to an observer who is vertically up above the liquid. The object M and its image will appear to be separated by how much distance? Very interesting answer. Let's see. This situation, I will convert it into a much simpler problem. I'll tell you how. This is actually nothing but whatever liquid is there on the top will get replicated because there is a mirror. So think as if the liquid just got replicated. So whatever liquid was there over here, that liquid will just get replicated below over here, just double of it, and our object was over here, right? This was an object, a small object, capital M. This was our object. What will a mirror do? It will reflect it as it is. There is no question of apparent depth for a mirror. So d distance below, exactly the M's image will be formed. This will be M prime. I'm going to call it image. Now it is obvious that the separation between them really or actually, because this is d, the image will be reflected exactly d distance below. So d and d together will make it obviously 2 times of d. Will make it obviously 2 times of d. But do not forget, our observer is somewhere over here. Our observer is somewhere over here. So for that observer, everything will appear to be shrunk. So the apparent height of separation will be actual upon the refractive index. So actual is 2D, refractive index is M. So 2D by M, which is B option. That is the right answer, not multiplied by M, it is divided by M. Got it, guys? It's a very nice question because it involves reflection inside a liquid surface. See, for a mirror, whether outside medium is air, vacuum, liquid, glass, how does it matter? Reflection laws are always valid. Object distance is going to be image distance. So naturally, it will reflect it at the same distance. It will not be less or more. Only problem happens when you see it from outside, because then the medium change will happen. The rays will get refracted. So it will not appear as if this is this large. It will appear to be little bit shrunk. Only when you are outside some medium. But if there was a fish observing it, if there was a fish inside the water observing it, the fish will still see the separation as 2D. Only if you take it outside, that's when the changes are. Got it? Okay? Because there could be a question, there is a swimmer or a diver inside the liquid and what separation will he see? Then the answer is just going to be 2D. There is no change at all. Alright. Let's move to the next question coming up on your screen. Some water is filled in a container till a height of 30 centimeters. If it is to appear half filled to the observer when viewed from the top of the container, the height up to which the water should be filled in it is how much? Okay, let's draw the container. Without that, obviously we cannot proceed. So let's say this is the container. Okay, let's say this is the container and the person observing it is over here, and we have to fill it in such a manner. That it appears to be half filled. So let's say, for example, I have filled it till here. What happens is the base of the container appears to be lifted a little bit, maybe like this. So this distance equals to this distance. So think as if this is the actual height till which you have filled it, and the whole container had a total length of 30 centimeters. So it is natural that this much will be 30 minus h. Now, as per the given question, because this was the real base of the container, this was the apparent base of the container. So this particular apparent base is exactly going to be 30 minus h. That is what the question says. Okay, the container appears to be half filled. So it feels as if whatever is there on the top is there below. So this much empty part is the full part, is what is the notion. But do not forget, this 30 minus h is actually the apparent depth. This is nothing but the apparent depth from the liquid surface, how deep you are from the liquid surface, which is nothing but whatever is the actual divided by the refractive index. And the actual depth is h, refractive index is 4 by 3. It's natural now you cross multiply, I think, or just write this as 3h divided by 4. So it will become 4 times of this particular number 30 minus h is equal to 3 times of h. Is that right? 30 minus h into 4 will be equal to 3h. Therefore, 120 minus 4h is equal to 3h. 4 and 3 becomes 7h is nothing but 120. So what is h going to be? 120 divided by 7 centimeters. How much will it come out to be approximately, guys? How much will it come out to be approximately? Guys are saying 20. Are you sure? 120 by 7 is 20? No, guys, come on. Something is wrong with you. Yeah, come on. 18 sevens are 126. 18 sevens are 126. So it has to be slightly less than 18. And it has to be also more than 17. So it will be 17 point something, but more close to 18. So this is very close to 18 centimeters, not 20 centimeters. I have seen many people do this question wrong. They do it by wrong methods to get the wrong answer. Let me tell you, you will get a perfect integer answer using wrong methods. And that is definitely not the answer. Okay? Be careful. Yeah. So depth equal to real depth by refractive index? No. This apparent depth is the part which is there on the top. That is the correct answer. Got it? Cool. So Guru, it is not 20 centimeters. It is 17 point something, which nearly is 18 centimeters. Got it? So be very careful. This question has come in JEE multiple times, even in many other exams like VIT, EEE, BITSAT and all of that. But values get changed. The refractive index will change. This value will change. These two numbers will change. And they will ask you what is the answer. Sometimes, by the way, they can ask the empty part is 1/3 of the part which is filled, or the empty part is double the part which is filled. So those kind of things you can manage, because then this will be not necessarily equal to this. This might be double, 1/3, twice, thrice, whatever. Then you can just make that equation and solve it. Cool. So this is how you are solving it. So what happens is when you're seeing it, you feel that it is half filled. So you really do not know that the base of the container is here. You feel that the base is here. So whatever is empty part will be the full part. Keep that in mind. Okay. So this is what the person will feel the water is there. But actually the water is there till here. Keep that in mind. But for that person, he will feel that the water is only there till here. He will feel that the water is only there till here. So this part is not existing. So that's why this and this are equal. Keep that in mind. Cool. Okay. Moving on to the next question on your screen. A double convex air bubble in water will behave like. In water, is it? So if you take water as the medium or some refractive index, this is your medium. So now think, guys, how will the rays refract? This is your bubble. Okay. So if a ray enters this, normally it will just pass normally. There will be no change at all, right? So that part is very obvious. A ray going like this will just keep on going like this. There is no change. But let's say you take some other ray over here. Then just draw a perpendicular like this from the center, you will immediately notice this is your angle of incidence over here. And the moment you notice this is the angle of incidence, you are going from dense to rare, you should move away from the normal line. So it will probably go like this. This particular ray will go like this. It will not bend towards it. Okay, it will not bend towards it. It will rather bend away from it. Keep that in mind. It will not bend towards, it will bend away from it. And once it reaches here, again a refraction will occur at this particular point. Again a refraction will occur at this particular point. This time you are going from rare medium to dense medium, so it should bend towards the normal. So you will see it will bend towards the normal, not away from the normal, towards the normal, like this. So our ray has gone like this, and like this. So a parallel beam goes like that. It is definitely a divergent beam. And anyways, it is a known fact that whenever you consider a lens which is denser than the outside medium, it behaves normally. But when the lens medium is rarer compared to the outside medium, it behaves exactly opposite to the way it is supposed to behave. So normal convex lens, what it should do? It should converge. But imagine if it is placed in a liquid which is more dense, then instead of converging, it will become diverging. So that is the whole idea. Because this is a convex lens, usually it should converge, but outside medium is rare, so it should be divergent. So two ways of solving it. Either you know the theory concept or you draw the ray diagram. Ray diagram will be lengthy, but if you know the concept, immediately I will mark it as option B. Got it? Yeah. Yeah. This came in your half yearly exam. Wow, nice. So directly you should mark whenever outside medium is rare, then normal behavior. When outside medium is dense, the exact opposite behavior. Concave will behave like convergent and convex will behave like divergent. Okay, so opposite behavior in denser medium. Keep that in mind. Moving on now to the next question coming up on your screen. Let's see if you guys can solve this. A radii of curvature of both the surface of a convex lens of focal length f and power p are equal. One of the surfaces is made plane by grinding. So then what is the new focal length and everything? Okay. So what it means is, see, you have a convex lens like this of equal radius of curvature. So in that case, the power will be equal to 1 by f using lens maker formula. It will be mu minus 1, right, into 1 by r minus 1 by minus r using sign convention. So that will just become mu minus 1. 1 plus 1 is 2. So it will become 2 divided by r. So that is your power, which is also 1 by focal length. But now you have made one of the surfaces flat by grinding it. So something like this. You have just grinded it. So it becomes a plano convex lens. So the new power and the new focal length will be simply refractive index minus 1. You will have 1 by radius of curvature minus 1 by flat surface will have infinite curvature. Is that right? So what will this become? This will become mu minus 1 divided by r. That's all. So this is P1, which is also 1 by F1. Now if you compare clearly, you will see whatever is P1, double of that is P. So clearly our old power is nothing but the new power multiplied by 2, because this is mu minus 1 by r, this is 2 times of that. So my new power will be old power divided by 2. So p by 2 should be there. P by 2 is only there in this option. So D option will be the right answer. Obviously, this is also correct because you can see that 1 by f is again double of 1 by f1, and we want basically f1 value, so it will be 2 times of f. So 2 times of f is also there over here, okay, nowhere else. So that is the answer. Cool? Yes, very nice. Moving on to the next question coming up on your screen. A convex lens of refractive index 1.5 has a power of 3 diopters. It is placed in a liquid of refractive index 2. What is the new power? A common sort of question. Let's see how do we do it. although you might have solved this before, but still you should be habituated to solve this question very quickly, because this is a very likely question. 100% it can come in your exam. So power is given. What happens when the liquid changes? We all know power, which is 1 by focal length, is refractive index of that lens by refractive index of that medium, the whole thing minus 1. And here you will have 1 by R1 minus 1 by R2. Now if you take it 2 times and if you divide the power, so power when in that uh, medium divided by the power in air, the difference will be not over here if you take the ratio, because anyways that will get cancelled in the numerator and denominator in these terms, but this is the place where things will change. The refractive index of the lens is 1.5 when you're in that medium. What is it? 2 minus 1. Whereas power inside air, refractive index will remain the same, but refractive index of air is 1. So this is how it will look like. These terms will not be necessary because anyways they are cancelling. Did you understand? When you are in the medium, refractive index of the medium has come. When you are in air, refractive index of air has come. Lens refractive index has changed, has remained the same. It has not changed. And this value is already given to me. The lens has a power of 3 diopters. So this is nothing but 3. So therefore, power in that medium divided by the number 3. 1.5 is 3 by 2. 3 by 2 into 1 by 2 is 3 by 4. So it will become 3 by 4 minus 1. This will be just 3 by 2 minus 1. So therefore, Pm divided by 3 will be 3 by 4 minus 1 is how much, guys? 4 will go minus 1 by 4. Minus 1 by 4. And this will be nothing but 1 by 2. So this will become negative 2 divided by 4, which is negative 1 by 2, is nothing but Pm by 3. Therefore, Pm is minus 3 by 2, which is negative 1.5 diopters. So the new power of the lens magnitude wise, yeah, it is 1.5. Yeah, so there is the answer. There is the answer. I hope this is clear. Magnitude wise, it is 1.5. So in this question, negative sign is not there, so don't get scared. They are probably asking the magnitude of it, or they should have mentioned it. Okay, if negative 1.5 was there, you will mark that as the answer. But here it's okay, it is understood. We have to calculate the magnitude of it. Okay, moving on to the next one coming up on your screen. Ready for it, guys? Be ready. A concave lens refractive index has both surfaces of radius curvature r. If it is immersed in a liquid, it will act as what? What will it act as? That is the question. Think. Okay. So let's do this. 1 by f will be equal to refractive index of the lens, which is 1.5, upon refractive index of the liquid, which is 1.75, minus 1 radius of curvature 1 by r minus other radius of curvature negative r. This comes because of the sign convention aspect, or else if you do 1 by r minus 1 by r, it will be 0, then it is meaningless to solve it. So this will become 1.5 is 3 divided by 2. What is 1.75, guys? 1.75 means it will be what? 7 by 8. Yeah, this will be 7 and this will be 8. Okay, perfect. And this minus 1, and over here you will be having 2 divided by r, because minus minus is plus, 1 plus 1 is 2. Okay, now couple of things will get cancelled. 2 will cancel with this will become 4. All right, so 2 fours are sorry 3 fours are 12 and 7 over here. So 12 minus 7 divided by 7 into 2 divided by your r. So that is 5. 5 twos are 10. So 10 divided by 7r, that is 1 by f. So f is nothing but 7r divided by 10. 7r divided by 10, guys. Just see if we have taken everything correctly. Yeah. Yes, so this is positive, so it has to be convex for sure. Yeah, just see if we have done everything correctly, guys? Did we make anything wrong? 5 to the 10.7. This should be 3.5 hour. Did we make a mistake somewhere? Just see. One second. I think we made a mistake over here. 1.75 is not 7 by 8, guys. Why did I do it like this? So sorry. Huh, that's where I made the mistake. Yeah, see, this is kind of silly mistakes which happen in the examination. It was 7 by 4. I took 7 by 8. So this was 3 by 2. 1.75 will be nothing but 7 by 4 minus 1, and this will be 2 divided by r, because 1 plus 1 is 2. Okay, and 3 fours are 12. Okay, this 2 will cancel. 2 into 3 is 6 divided by 7 minus 1 into 2 by r, which is nothing but, what is it? 6 by 7, that will become minus 1 by 7 multiplied by 2 divided by r. But remember, that is 1 by f. So f will be nothing but negative 7r by 2. So what does this negative sign tell me? Negative tells me it is definitely concave. And this magnitude is nothing but 3.5 r, that is the focal length. So focal length is 3.5 r, and negative sign is telling me it is going to be a concave. So it not a convex, it is going to be a concave. Yeah. Be careful, guys. This is 6 by 7. This is 6 by 7. But wait a minute. We have made another mistake over here. This was a concave lens, guys. This was a concave lens. This was not a convex lens. So actually these numbers will change. Okay, let's redo this question again completely so that there is no confusion. My bad, guys, in solving this. Let's do this again. So we have a convex lens, sorry, we have a concave lens. So when it is a concave lens, R1 is negative and R2 is going to be positive. So the power, which is going to be 1 divided by F, will be refractive index of the lens, which is 1.5, divided by refractive index of the medium, which is 1.75 minus 1. And then here, first number will be 1 by negative R, and second number will be 1 by positive R. So in case of convex, it is 1 by r minus 1 by minus r. So for concave, it is negative. So that is something which we need to keep in mind. So therefore, P will be equal to 1.5 is 3 by 2, 1.75 is 7 by 4, and this is minus 1. And minus minus will come 2 times. So minus 2 divided by r over here. And 2 and 4 will cancel. 2 times 2 threes are 6. So 6 by 7 minus 1 into minus 2 by r, which is 7 and 6. So 6 minus 7 is minus 1. So minus 1 by 7 into minus 2 by r, which is 2 divided by 7r, which is nothing but 1 by f. Therefore, f will be equal to 7r by 2. Now, since the answer is positive, then it will be a convex lens, and whatever is this value, which is 3.5, that will be the magnitude of the focal length. So 3.5r, and it will be a convex lens, not a concave one. So if it was a concave, it will be negative. If it was a convex, it will be positive. So that is the answer for it. Okay. Yeah. So keep it in mind. Yes. So keep it in mind. Cool, guys. So concave is behaving like convex, and the reason for that is you will see refractive index of the medium is higher than the refractive index of the lens. So the behavior will change. The behavior will have to be exactly opposite. All right. Moving on now to the next question. It's a very similar question which you can do it as homework. So medium has changed. What will be the new power or the ratio of the powers? So I have kept it as homework. Will you be able to do this question? Okay. Sir, can we say due to the lens from rarer to denser medium, we can say property changes to? Yes, Shraddha, you can say that perfectly. Every time the refractive index is higher, the property will change exactly to the opposite behavior. Let's go to the next question then. All right, great. So this is your homework question. Mark the answer and put it up in the comment section later on after the session is over, not now. And you'll get the entire PDF with the answer key after the session is over by tomorrow. Okay. A convex lens of focal length 1 by 3 meters forms a real inverted image double the size of the object. The distance of the object from the lens is. Interesting question. Let's try to solve it. This is your lens. Principal axis. We have an object over here. We have an object over here. It forms a real inverted image. So that real inverted image is right over here, which is double the size of that particular object. Okay. The distance of the object from the lens is how much? Focal length is also given. Now, first things first, let's think if this distance wise is x centimeters, this distance wise is y centimeters, my image distance will be positive value and it will be positive y. My object distance will be a negative value, so it will be negative x because this is the negative side, this is the positive side. Being a convex lens, the focal length will be here and focal length will be also positive in nature. So let's use our lens formula and try to see what exactly do we get. Okay, let's see what exactly can we get. So if I say 1 by V minus 1 by U is equal to 1 by F, I know the focal length is a positive number, 1 by 3 meters. So I'll just put everything in meters only then, 1 by 3 positive value only. Object distance and image distance. Object distance and image distance. Image distance is basically y and image distance is basically minus x. So this will become 1 by y plus 1 by x is nothing but the number 3. 3 goes on the top. But these are two variables. I don't like two variables. I need to convert it into a singular variable. So for that purpose only, this is given to me. Inverted image double the size of the object. So the magnification itself is -2. Do you understand why it is -2? Why not +2? It is inverted, so negative. So this inverted means negative, and twice means the magnitude. The magnitude of that magnification is 2 times. And magnification formula for a lens is V by U. So I have to use V by U formula. What is V? It is nothing but Y. What is U? It is basically minus X. So that is -2. So from this, minus minus cancels. I will get Y is nothing but 2 times of X. Y is nothing but -2 into minus X, which is positive 2X. I think now we can substitute that Y over here, whatever this Y you get, as 2X. That will now simplify it in one singular variable. So half plus 1 is 3 by 2. By the way, this was 3. So this will be 3 by 2 times of x is equal to 3. 3, 3 cancels. So 1 by 2x is equal to 1, right? So therefore 2x is equal to 1. Therefore x is equal to half. Therefore x is nothing but 0.5 meters. What is x? X is object distance. So 0.5 meters, which is option A, is the right answer. Got it? So 0.5 meters is the answer. Very good. Great. Many of you got it correct. Very good, Pavi. Yes, Guru. Yes, Sabri, Nathan. Yes, Lewis. Amazing. Amazing. Yeah. So if you take the sign convention properly and if you use it in the right sense, you'll get the right answer. Let's say you had put one extra negative sign here, then the answer would have changed completely. Because then it will be minus 2x and minus half x plus 1 by x will be negative, plus half x. So you will get a completely different answer. So be very careful with sign because a small difference in these equations completely gives a different answer, which gives you the negative marks. Moving on to another question coming up on your screen. The size of it is a real image by the convex lens. It is a real image by the convex lens. Has to be on the other side. It will be inverted. Okay, so this is our object, this is our image, this is the positive side, the focal point will be somewhere here, this is the negative side. Let's start assuming couple of things. Let's assume this distance as x, let's assume this distance as y. So my image distance will be positive y and my object distance will be negative x. If the image is m times the size of the object, understand that the magnification is not m, rather it is minus m. It's like saying the image is double or triple. So the value of small m is basically 3 or 2, but magnification is not 2 or 3 because it's inverted, so it is minus 2 or minus 3. So that's why this negative sign comes, which is a very nice catch in this problem. If you miss this, you're gone. And magnification formula is V by U, which is then minus M, and V value is Y, and U value is minus X. So this is minus M. So from this, we'll get Y is minus M multiplied by minus X. Therefore, Y is equal to MX. Y is equal to MX. Till this point, absolutely clear. Now just use your lens formula, which is 1 by V minus 1 by U is 1 by F. Is the focal length given? Yes. Is the image distance known? V. V is Y. So from this, therefore, V, because it is Y, it is nothing but MX. So I can just put, instead of V as MX, object distance is just negative X. There you go. So this will become positive. So 1 by mx plus 1 by x is 1 by f. LCM is mx. So it will be m plus 1. It is 1 by f. What do we need to figure out? We need to figure out the image distance, is it? That is y. Okay, not an issue. So from this, we will get x is equal to, we'll get x on the top is equal to f into m plus 1 divided by m. F into m plus 1 divided by m is nothing but the value of x. But I don't want x, I want image distance, which is v. So therefore, image distance, which is m into x, x is nothing but f into m plus 1 divided by m. M will cancel, so it will just become f into m plus 1. So that is your image distance, f into m plus 1. C option, absolutely right. Okay. Sir, how we know it is inverted? Okay. Basically, who is asking this? Koro. If you remember 10th standard, you had drawn those nice, beautiful ray charts, diagrams, different places where the image is formed. So that is something which you need to remember now. Okay, you cannot ignore it. So you should know it as a fact. When approximately for which type of mirrors and lenses, what kind of images are formed, you can remember it or you can draw it, and that's how you remember it actually. So you do it 2-3 times, those ray tracing. So object is here, where is the image form? Object is here, where is the image form? So approximately if you know, then you get the answer. But as a simple rule of thumb, guys, for convex lens, always the rays will converge. So what will happen? The rays will converge and give you a real image. Except for when you are bringing it too close, then it becomes virtual image. Okay, that is very close, then it becomes a virtual image. Other than that, it always gives you a real image. For a concave lens, what happens? The rays will diverge. So usually you will see a virtual image, okay, because the rays will diverge and you have to always retrace it back. So that's how I know whether, it will be real, virtual, and all those things. How about inverted? Think about it like this. If you have this particular lens, if a ray is going parallel, then after refraction, it will go like this. And any other ray which passes through the center, it will go like this, undeviated. So wherever the object is, let's say on the top, the image on the other side will be exactly opposite side of the principal axis. So it gets inverted. So most of the times you will see the inversion happening unless a virtual image is formed. Got it? Yeah, amazing. So these are some real good questions, guys. So I hope you are loving it. And a very similar question I'm giving it to you as homework. Please tell me you can do it. Put some fire emoji in the chat box right away right now. Convex lens of focal length produces real image whose size is n times size of the object. The distance of the object they have asked instead of the image. So very nice. Similar question is there. Tell me if you can do it. Fire in the chat box, guys, right away right now. Yeah, very similar. So these questions, please practice. You will see many PYQs are based on that. I have not really taken PYQs because I want you to solve those PYQs after this, or we'll take PYQ marathons also after this particular sessions from January 1st. Okay, so this was your homework question. Let's go to the next one coming up on your screen. Whoa, we have come to prisms. Let's see. Okay, ready for it, guys? Okay, nice to see that, Josh. Keep it up. So, what's the question? The question says a light ray passing through an equilateral prism. Equilateral prism, guys. Angle of the prism is 60 degrees, such that incident angle is equal to the emergent angle, and the angle of emergence is equal to 3/4 of the angle of prism. Oh my god, wait a minute. Angle of emergence E is 3/4 the angle of prism, which means it is 3/4 of 60 degrees. 60 by 4 is 15, 15 degrees of 45 degrees, number one, such that the angle of incidence is equal to the angle of emergence. So angle of incidence is equal to the angle of emergence. Therefore, I also happens to be equal to 45 degrees. Just check this out. Everyone, till this point, absolutely clear? I and E both are 45 degrees. Now the question is, what is the deviation angle? Deviation formula, guys, try and recollect. It was I plus E minus A. So 45 plus 45 minus 60. 45 plus 45, 90. 90 minus 60, 30. So angle of deviation is 30 degrees. B option for IIT Bombay. Straight, simple, direct. No, not D, not D. It is B option. It is not D option. They have not asked incident angle or emergent angle. They have asked angle of deviation, which is delta, how much the ray gets deviated by. That's a different story altogether. Yeah, this is a standard formula if you remember. Yeah, we have done this. Cool? Paka? Amazing. Let's go then to the next question on your screen. Oh, I've kept some diagram also. A ray of light is incident on the first face of an equilateral prism. That means angle of the prism A is again 60 degrees. At an angle of incidence I, the emergent ray grazes through the adjacent face. The refractive index of the prism is root to the value of incident angle in the first faces. See, I'll just give an approximate diagram, then we'll go to the real one. So if this is the equilateral prism, the emergent ray is grazing along the adjacent face. That means it is going like this. Okay, emergent ray is basically going like this. So the ray would have an incident maybe like this over here, and then it is coming like this over here. So this is exactly what is happening. It is grazing. So wherever it is grazing, this will be 90 degrees, obviously, and this will be the angle of incidence. And this is basically 60 degrees. So this is the diagram. Diagram is not given, they explain it in words. So always start with the diagram first, otherwise you will be stuck. Okay. Now question is, refractive index is given. What is the value of the angle of incidence? If you want to find I from this piece of information, there is no other option now but to actually figure out how much is this, and this is R1, because you can use Snell's law because the refractive index is given. So from that we can find I if I know R1. But to find R1 from angle of prism, I need R2, and to find R2, this data is given that emergent ray is grazing the surface. So using Snell's law, we'll get R2. From R2, we'll get R1. From R1, we'll get I. So that is the mental process I have set up. Now we'll actually put it into implementation. Okay, so I just drawn the diagram for all of you. I hope it is clear. It's the same thing. It's looking very, yeah, glowy. Anyways, so what will we do first? First, let's figure out R2, guys. That is basically the critical angle now. So grazing means it is the concept of total internal reflection. So R2 is nothing but the critical angle, which is 1 by is nothing but the critical angle. So therefore, sine of R2, which is going to be 1 by refractive index, which is 1 by root 2. So guys, 1 second, guys. So therefore, my R2 will be 45 degrees. R2 is 45 degrees. What next, guys? Think, if R2 is known, A is known, we can find out R1. There is a formula. What is that formula? R1 plus R2 is the angle of prism. So therefore, R1 plus 45 degrees is angle of prism. So therefore, R1 is nothing but 15 degrees. Oh, great. We got R1 also. Now what do we do? Yeah, we just have to figure out what is angle of incidence. So for that, use Snell's law. So mu is sine of angle of incidence divided by sine of angle of refraction. In this case, it is R1. So refractive index is root 2 is equal to sine of angle of incidence, sine of R1. So this will be sine of 15 degrees multiplied there. So sine of incident angle is root 2 times sine of 15 degrees. Therefore, angle of incidence is sine inverse of root 2 times sine of 15 degrees, whatever is this. So this is the answer, and I think that option is there. Sine inverse of root 2 times sine 15. They have not asked us to calculate sine 15 value. They just wanted to see whether we can approach the problem, and that is what JE does. Yeah, option A. Love this question, guys. Usage of Snell's law, concept of total internal reflection, and also geometry and the formulas of the prism. Like R1 plus R2 is A. This is one formula. Deviation is I plus E minus, angle of prism. These are, important formulas which you should know for the prisms. Cool? Amazing, amazing. So that was the answer. Yes, perfecto. Let's go to another question, and we have another diagram which is going to come up. This is good question, guys, I feel. A monochromatic ray of light is incident normally on a thin prism, interesting, thin prism of refracting angle A. The ray is deviated by a very small angle, very small angle. So small angle approximations are there. That is why they have mentioned the word thin. You can see the angles are also very small. So maybe I might need approximations in this problem. The ray is internally reflected from the second phase, emerges from the first phase, making an angle of 6.3 degrees with the incident ray. Interesting. The refractive index of that particular prism is how much? It's a very, very good question, guys. Let's try to think and solve it properly. Ready for it? So let's understand what is happening. We have a thin prism. We have a thin prism. We'll not show it very thin, or else it will be difficult to draw and mark everything. The ray of light is coming like this. Ideally, it would have gone like that, but it gets deflected, of course. It gets deflected, and what happens? It goes like this over here. It goes like this over here. 1 second. Like this over here. The ray is deviated through an angle of 1.15 degrees, is passing through the prism. The ray reflected internally. Okay, so again, it will finally come out like this. Now, if you extend this versus take the original path, this angle is the angle of deviation. That is basically your deviation. The ray is deviated by how much? 1.15 degrees. That is your delta. But the ray also gets reflected internally from the second phase. meaning it gets like this, goes internally reflected here and emerges from the first face. So over here it will come out from first face like that. This is what is also given to me. So there is partial refraction and partial reflection which is happening on that incident ray. This is the ray diagram. See if you have understood this till this particular point. Everyone? Everyone? Yeah? Okay? Akka? Clear? Very good. Amazing. Now, another important thing is that actually the light ray which is falling onto it is perpendicular. So the ray diagram which I have drawn should not be like this. This is a generic case. So actually it is falling, if you think carefully, this is not really over here. That ray actually is falling normally. It is actually falling normally over here and then getting deviated. And the final ray which is coming out, that final ray is making a very small angle of 6.3 degrees with the incident ray. Meaning, so when it comes out like this, when it comes out like this, it's making a very small angle. It is making a very small angle of how much? 6.3 degrees with the incident ray. So if you take this as the incident ray, this angle over here is 6.3 degrees. This is the incident ray. With the incident ray, it is making 6.3 degrees, the final ray which emerges out. So that's the final ray diagram. Now, let's solve the question. Ready for it, guys? This diagram, if you don't draw it properly, you will make hundreds of mistakes. So I just marked everything for all of you. The same thing. I didn't want to show you this diagram before, because then what will happen? You will assume many things. When you creatively do it from the scratch, then you will understand it. Okay. So this was our original ray, if you remember, which went straight like this. This was that ray which got deviated over here. This was that particular ray which got reflected here, and finally it emerges out at some angle. Finally emerges out at some angle. Okay. So first of all, as you can see over here, since it was given that it is a normal incidence, therefore this is 90 degree. Refracted is also 90 degree right over here. Okay, very simple. Angle of the prism, the angle of the prism is already given. This is equilateral prism or something. No, it is not. It's just that it is very small. Okay, we can't do anything with that angle of prism. Nothing we can do. Okay. Now, next thing, the ray gets deviated. So the deviation angle is right over here. That is basically your delta. That is basically your delta. See, guys, if you drop a perpendicular over here, if you drop this particular perpendicular over here, that is the normal ray. Since the ray gets internally reflected, this and this angle should be equal. Now, in this particular triangle, this is 90, this is A. How much will this be? This will be 90 minus A. Are you getting my point? Why that will be 90 minus A? If this is 90, this is A. This particular angle will be 90 minus A. So if that is 90 minus A and this is a normal which is drawn, naturally this angle should be A. So that is why I am saying that this particular angle that you see over here, this particular angle that you see over here is actually going to be that same A. And because laws of reflection, incident angle should be reflected angle. So this angle should also be equal to A. Understood till here? Everyone? Very good. Now, if this angle is A and this ray continued straight, then opposite angles are equal. So naturally, this particular angle is also going to be A. Whatever the direction of the rays, if you continue along that same particular path, obviously these two angles will be opposite. So this is also going to be A. Okay, fair enough. Perfecto. All right. Now also notice one more thing. this surface, this light ray is getting refracted. So technically, this becomes your angle of incidence for it. This becomes your angle of incidence for it. And this whole thing becomes the refracted angle. Refracted angle. Think about it. From the normal to the refracted ray. This was your refracted ray. That is another thing. Next, because this ray was perpendicular, if you draw one more normal here, these two rays will be parallel to each other. These two lines, this line and this perpendicular, will be parallel to each other. Now, if that is the case, if this angle totally is a plus a, which is 2a, this is an intercept. So that's why this angle will also be 2a. Getting my point? If this is A and A, this is 2A. This is an intercept drawn to two parallel lines. That's why this is 2A. And the final angle by which it emerges is 6.3 degrees. It is given in the question. So this much level of geometry is required for solving this question. Okay? Fair enough till this point? Amazing. So now let's start applying whatever law we can use for this particular question and try to solve this. Let's start with this particular thing because this is refracted. Maybe I can get something here, then I will look into this aspect because this is happening later on. First, I will concentrate over there. At this surface, what is this? Add this surface PR for refraction, which is happening. If I use Snell's law, inside the refractive index is mu. I think it is not given. In fact, that's what is asked. Into sine of angle of incidence. As you can notice, with the normal, the incident ray is making A angle. So sine of A is equal to, outside the medium is air. So refractive index is 1 multiplied by the angle of refraction, which is just marked over here, which is sine of A plus delta. Okay, till this point, absolutely clear, everyone? Very good. But we all know, since it's a thin prism, sine A will be A, sine of A plus delta will be A plus delta. So I can just say mu multiplied by A is approximately A plus delta. I'll just keep it as it is. Okay, I'll just keep it as it is. I'll not do much as of now. Anyways, next let's focus on, let's say I call this as equation 1. Sir, how did we just remove the sign? Small angle approximation, man. Remember this? Because thin angles, so for small angles, sine theta is roughly theta, which is also tan theta. So sine theta can be just written down as theta, provided it is in radians. Okay? All right? Cool? Is it lagging? Screen lagging? Just refresh, just check it out. I don't know why during my sessions only YouTube has to go down. I feel what we can do is probably we can divide both of them and see what we get. Yeah, let's divide both of them. So dividing. So let's divide 1 and 2. And let's see what do we exactly get. On first and second. Second, it has 2 mu A over here. So 2 mu A. And here it has just the value of E. And on the numerator side, it has mu A. It has just mu A. And on the right hand side, it has A plus delta. All right. So let's see what happens. A and mu gets cancelled. So half is equal to A plus delta. Delta value is 1.15 degrees. Emergent angle is basically 6.3 degrees. Okay, multiply this. So 6.3 degrees is 2 times of A plus 2 into 1.15, which is 2.3 degrees. So therefore, 2 times of A is 6.3 minus 2.3, which is basically 4 degrees. Therefore, angle of prism is 2 degrees. Just check if everybody got angle of prism as 2 degrees. Once you get the angle of prism, as 2 degrees, I think we can solve it using maybe either this equation or even this equation, anything works. So let's say you use equation 1. So in equation 1, if you substitute it, let's see what do we get. In equation 1, mu into A. So mu multiplied by A, which is 2, is equal to 2 plus delta, is equal to 2 plus delta. Delta is 1.15, which will make it 3.15. So mu will be 3.15 divided by 2. Therefore, how much is the value of mu, guys? Yeah, 1 point, how much? 3.15, 1.5 and 75. Just check this out. 1.575. That should be the answer. Let's check it out. Yes, that is the right answer. Amazing. So this had more of geometry than the actual solving, because that first initial geometrical part, one thing you had to, visualize what is happening. Okay, so draw the diagram, then start marking all the possible angles, what are equal, what is not equal, what is double, what is small, what is big, everything you start marking. Then you start applying Snell's law, and then you use small angle approximation, and then it is straightforward. It had just two equations, if you notice, nothing else. One equation and second equation. That's it. Apart from that, physics was over. We just use maths over here. Cool. Loved the question, guys. Shall we go ahead? Okay. Let's move to the next question on your screen. A convex lens. There is a convex lens which is having a focal length of 40 is in contact with a concave lens of focal length 25, the power. So whenever lenses are in contact, the powers get added, the reciprocals of the focal length get added. So that's it. So my dear warriors, power of the combination is 1 by, or you can just say it is P1 plus P2, which is 1 by F1 plus 1 by F2, since focal lengths are given. Convex focal length is 1 by 40, so over here, plus concave focal length 1 by 25. Do not do this, put negative. Many people will miss the negative sign and get a completely different answer. Okay, that's all. So 40 and 25, guys, if you want, take the LCM, which is going to be 200, let's say. So 40 goes with 200 5 times, 25 goes with this 8 times, so minus 3, is that right? 25 centimeters, yeah, 3 by how much? 200. Okay, so that is in centimeters. So we need to convert it into meters. So this was, remember, centimeter inverse. So if you convert it into meter inverse, it will be minus 3 by 2 meter inverse. Now minus 3 by 2 is nothing but minus 1.5. Meter inverse is exactly the value of diopter. So the power is negative 1.5 diopters, which is option A. Yes, that's absolutely correct. Cool. Yeah, option A, very straightforward. Nice. Very good, guys. Let's move to another question coming up on your screen, and here it is. Two lenses are combined. What is the combined focal length? It's opposite of the previous question. So we know that the net power is P1 plus P2, and that net power will be 1 by F. So that will be P1 plus P2. So P1 is minus 15, P2 is just 5, so it will become minus 10. So F value will be minus, but remember, okay, okay, whatever. This will be minus 1 by 10, which is minus 0.1 meter. Minus 0.1 meter means minus 10 centimeters. So this negative sign indicates that it is a concave lens as a combination. So negative 10 centimeters is the answer. Minus 0.1 is there because many kids are going to forget this. It is going to be in meters. So they'll forget the conversion factor. So many kids are going to mark this. And I can already see many kids are marking option A. See, I just guessed it. I just thought, I didn't even look at the chat box as of now. And now I am seeing it. Already many kids have marked minus 0.1. Got it? So be very careful. It's a simple question. That's what I told you. You guys are thinking that hard questions will give you more marks. Actually, easy questions are taking away your negative marks. It's not the hard questions. So these things we have to be very, 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 very careful and alert, guys. Okay? Okay. Let's go to the next question coming up on your screen. And here it is. What does it say? An optician makes spectacles having combination of convex focal length in contact with concave focal length, the power of the combination. Now this also you can do easily. Yeah? Pakka? You'll be able to do it? Yes or no? I'll just keep it as homework. Again, this is your homework question. So make sure you solve it. All you have to do is find the power of that combination, which is P1 plus P2, which is 1 by F1 plus 1 by F2. Focal length are given, that's it. Add them, you will get the answer, but convert it into meters, else you will not get the right answer. Okay, I'm not showing the answer will be there on the next slide. All right. The double convex length of focal length f is cut into two equal parts along the vertical axis. The focal length of each part will be on the vertical axis, meaning this is your convex lens and you are making that cut like this. So what happens is now you are getting one lens like this and one lens like this. This is the new lenses. This was the old lens. This was your old lens. Okay. So old focal length was f. What will happen? Guys, if you combine both of them, you should get this. So technically 1 by f. Technically 1 by f should be 1 by f1 plus 1 by f1. So it is 2 by f1. So take f1 on the top because this number 1 by f is below, f goes on the top over here. So it will become 2 times of f. So f1 will be 2 times of f, which is option A. So a lot of people think focal length will become half. It's actually the opposite. The focal length becomes double. It's the power which becomes half. So if this is P, the new power will be P by 2 and P by 2. But these focal lengths will actually be double. So this will become 2F and this will also become 2F because power is inversely related to the focal length. Cool? Got it? Yeah, option A. Very nice. Thank God. No. Oh, some of you said C also. See? Officer Earl, got it? Common mistake. I was knowing many kids will do this. So that's why these questions are there. Next one. Two thin lenses having R1, R2 as the radar of curvature, respectively, are kept coaxially together. Their power is proportional to. First of all, if you take any one lens, the focal length will be mu minus 1. There will be 1 by R1 minus 1 by minus R1. So that will give me this will become 2 times. So 2 into mu minus 1 divided by R1. Same way, the second focal length, which is refractive index minus 1, it has a radius of curvature of R2 like this. So this will become 2 times. So 2 times of mu minus 1 and this is divided by R2. Why I did this? Because I know their combined power will be P1 plus P2, which is 1 by F1 plus 1 by F2. So 1 by F1 and 1 by F2 are here only. So 2 into mu minus 1 by R1 plus 2 into mu minus 1 divided by R2. Now 2 into mu minus 1 can be taken down as common. So it will be 1 by R1 plus 1 by R2. So it is 2 into mu minus 1. This will become R1 plus R2. Okay, the whole thing divided by R1, R2. So as you can see, the power is proportional to R1 plus R2 divided by R1, R2, which is D option, which is nothing but D option. Got it, guys? Clear? What is it proportional to was asked. So just had to use lens maker formula 2 times. That's all. Perfecto. Shall we go ahead to the next question then? Here it comes. Plano convex lens fits exactly into a plano concave lens. Their plane surface is parallel to each other. The lenses are made of different materials. Radius is the same. Obviously, the combination is going to be. Okay, very nice question. See, it's like saying you have a plano, let's say convex lens, and then you are having a plano concave lens like this. and they both are perfectly fitting onto each other. So that's why the radius are same. Now they look like a glass slab, but don't be fooled into thinking their focal length will be infinity. No, the rays won't come out parallel because one side it will converge, other side it will diverge by different amounts. So they will not really become parallel after the final emergence. So that is a common mistake which many kids do. Alright, so let's try to find out the focal lengths individually so that we can find the focal length of the combination. First of all, for the plano convex, so 1 by f1 will be refractive index is n1 minus 1. So 1 by first surface is flat, so infinity, minus 1 by second surface is curved, so negative r as it is. So this will become n1 minus 1 divided by 1 by infinity is 0, minus minus is plus, so 1 by r. So n1 minus 1 by r, that is plano convex. For plano concave, refractive index is n2. Okay, first surface is curved, so minus r. Second surface is flat, so infinity. So this will become nothing but 1 minus n2 divided by r, because this negative sign, if I take it inside, it will become 1 minus n2, and 1 by infinity is anyways 0. Now let's try to figure out the power of their combination. That's what has been asked, right? No, focal length of the combination. So 1 by f will be 1 by f1 plus 1 by f2. So it will be n1 minus 1 by r plus 1 minus n2 by r. So anyways, the denominator is common. So n1 minus 1 plus 1 minus n2. So this will become 1 cancels, n1 minus n2 divided by r. But remember, this is 1 by f. So f will be r divided by n1 minus n2. R divided by n1 minus n2 is the D option. Very nice question this is, because it's plano concave and plano convex. Many kids will make a mistake in the signs only. Second problem is, you might get confused in these solving part, and you might get something else. Instead of n1 minus n2, you might get 2 times, or 2 will come on the top. Some silly mistake can happen. Okay? Very good. How many questions completed? You will get to know very soon. Don't worry. Don't worry. All right. Next, coming up on your screen, and here it is. Okay. An achromatic convergent doublet of two lenses in contact has a power of 2D. Now, what is the meaning of this? Let me just explain, because sometimes kids do not know it. It's very rare this question can come, but this kind of question has come previously in the JEE mains paper. So if you have two lenses, one concave and one convex. Now, usually what happens is, when you pass white light, all the colors ideally should have the same focal length, but it doesn't, because the refractive index depends on the wavelength. So each color will merge differently and will have different focal length. This creates a problem called as chromatic. Chroma means color. Chromatic aberration. Aberration means like a problem or an error, where you have some object which is multicolored. You expect the image to be formed at some place, but the image is blurred because each color is forming its own different image at different places. So the image is not very crystal clear, which causes a problem. And if you are using such a lens in your camera, of your mobile phone or digital camera or telescope, microscope, it is a big issue, because how can we have different colors forming images at their own different places? So that's why it is being corrected by using a combination of two lenses, one convex, one concave, or sometimes they use prisms also, by which they ensure that all the colors, violet, indigo, blue, green, yellow, orange, red, merge at the same point. That reduces the divergence of the, or the dispersion of the colors. Dispersion is the phenomena where colors get spread out because of different refractive indices. So you will see that the red color to the violet color, here the violet color might bend like this, and again it will form here. So you are removing achromatic means you are removing the color related issue. So it's a convergent beam. So as you can see, all these colors were, together before. So like this is your RGB, the famous colors, and they finally meet over here. So actually all these colors together over here, they become the white beam, isn't it? This is nothing but your white color. This was nothing but your white color. I hope this is clear. But finally, they are all meeting at the similar point. So you are removing that achromatic combination. Is this concept clear? Okay. Yeah. Doublet means two lenses. Now, first of all, because there are two lenses, the powers will get added. So P will be equal to P1 plus P2 naturally. The total power is given to be 2. The convex lens has a power of 5. So power of the concave lens will be obviously negative 3 diopters. This is for concave. This is for concave. The question is the ratio of the dispersive powers of the convergent and the divergent lenses. Now there is a formula for this. Now if you know this formula, it's okay, or if you don't know it, I'm going to tell it to you right now. The answer is basically dispersive power, if it is omega 1 for the first lens, by the power, let's say it is, you know, uh, P1 or P2. Okay. So usually what happens, you write omega 1 by f1, which is the focal length of the first lens, upon omega 2 by f2, because there is no chromatic aberration, achromatic combination. So the final answer is 0 because of achromatic combination. This is the net effect, and this values omegas are nothing but your dispersive powers. Dispersive powers. Dispersive powers. So omega 1 by f1 plus omega 2 by f2 will be 0 in case of such a combination. Now you shift it over here. So it will become omega 1 by f1 is negative omega 2 by f2. Solving it further, you can see what is asked, the ratio of the dispersive power. So omega 1 by omega 2 will be negative, omega 1 by omega 2 will be negative of f1 by f2. So which is nothing but negative of p2 by p1, because obviously it's inverse ratio. So p2, what is p2? It is negative 3. What is p1? P1 is 5. So minus minus cancels. So it will become 3 by 5. So 3 by 5, which is nothing but your option A. Got it? That's how you solve it. Okay. This is the formula which you should know. So omega 1 by f1, you can also write it as omega 1 p1 plus omega 2 p2. That is also perfectly fine. But I wanted to show you the exact formula, which is original formula, which is omega 1 by f1 plus omega 2 by f2, which is as good as saying omega 1 p1 plus omega 2 p2 instead of doing this. Anyways, we had to convert it into power. Cool. Next. So I've kept two weird questions at the end actually, because these questions are rare, but if it comes, many people will not know it. A concave mirror of an object placed at a distance x1 from the focus and the image is formed at a distance x2 from the focus, then the focal length is. Read the question carefully. It is not your usual distances. So you have your mirror. This is your focal length. This is your object. Let's say this is your image. Usually measure image and object distance from the pole, but this time you are measuring it from the focus. That's the catch. Focal length is measured anyways from the pole only, always. Then such a method where you write the formula is also called as Newton's formula. Imagine Newton had done work on optics also. This is Newton's formula, and Newton's formula says that you take x1 and x2 and take the root of it. What we will get is exactly the focal length. So that is basically the Newton's formula, which is option B. Which is option B. You should know this by heart. There have been instances even last year that they gave values. This is 5 centimeters, this is 7 centimeters, how much is focal length, like that. Those questions were also there. What people did is, sir, we don't know the distance of focus. So you assume this as f. So you found the distance from the pole as f minus x2, then f plus x1, then use mirror formula, then solve it. After doing all of that, also you'll get the same answer. But why to do all that unnecessary steps? Because it will be unnecessary complex equation. Rather use Newton's formula if distances are measured from focus for mirrors. For mirrors. Cool. Okay, perfect. Wow, guys, we have come to optical instruments. And we were already on which question? Question 28. Wow. Question number 29 on your screen now. And after optical instruments, we'll take a short break. Guys, come on. Surprisingly, this year, that is 2025, there was not even one question on optical instruments. Not even one. So, what everybody is doing in India right now? Naturally, nobody is doing it. But no NTA. You know NTA, right? So beware. I don't know who might be that unlucky person in that unlucky shift. It could be you watching this class. It could be somebody watching it as a recorded or somebody not watching it at all. At least you are watching it. So at least you are aware. The person who is not watching it is unaware, chilling out. Oh, optical instruments didn't come. I'm chill, bro. I'm not worried. I have done optics and prisms. Yeah, they are skipping it. Be careful. All right. So I don't know, guys, who that unlucky person might be. Okay. So you need to be prepared because if you're going to play a game of dice, you think nature will help you or, the odds are going to be in your favor. But, I have seen such bad luck with so many students, not one or two, many students. If you'll see in this chapter, if I leave this concept, it will not come. All a high weightage I have studied. In this chapter, okay, I will leave that where at least other 90% have studied. So like that, a kid had studied almost 70-80% of the entire syllabus. And it so happened, whatever he had not studied, exactly those questions have come. Most of the paper, not entire paper, most of the paper. Just imagine the state of that student. He has done 70-80% of the syllabus, feeling that this will not come, that will not come, left all those things. Exactly from that chapter, from let's say rotational motion, you have studied everything, but you just left radius of gyration. Exactly, radius of gyration. How you will feel? You will feel like running out of that place, throwing that paper, smashing that computer only, and running away, isn't it? So I just hope that luck is in your favor because people underestimate the power of luck. And trust me, luck also plays a big role. It's hard work too, but you can overcome that luck factor by studying so much that luck doesn't matter anymore. So that's what toppers do. Yeah. Oh, this happened with you in pre-boards. Oh my God. Sucks big time. Jaram trauma. I know, right? Imagine happening this in pre-boards, mock tests. Oh, by the way, I was such an unlucky kid. Whenever I used to study something for my boards, every time, same thing. I remember there was one in English, there was one crazy poem and one very complex literature which I never understood. I had left it that time. Exactly those have come in my 10th board examination. But I don't know, luck has changed for me in the last 10 years as a teacher. Whatever I'm saying, exactly those have been coming. So maybe I'm not lucky as a student, but I'm very lucky as a teacher. And I think it's good for you. Not great for me as a student, but it doesn't really matter. I'm no longer a student, right? Okay. Simple microscope is used to see the object first in blue light and then in red light. Due to the change from blue to red light, the magnifying power will what? Come on, guys. What do you think is the correct answer for this? Yeah, it's lucky for us. Correct. Magnifying power, bro. Come on. 1 plus d by f if it is distinct vision. If it is normal vision, then it is just D by F. In any case, F is below. That's one thing. Now for focal length, who is big and who is small? If you compare focal length of red versus focal length of blue, focal length of blue color. Come on, guys. Violet, indigo, blue. Violet deviates the most, so it has high refractive index. High refractive index means smaller focal length. So blue has smaller focal length than red because refractive index is higher. Refractive index for blue is higher than the refractive index of red for a simple reason. That's all. So that means if red's focal length is higher, the magnifying power will be less. The magnifying power will be less for red and the magnifying power will be more for blue. Hence the answer is decreases. So if you change from blue to red light, what will happen? For red light, it will decrease. Simple. Got it? Very straightforward. Great. Moving on to the next question. For a compound microscope, meaning you have two lenses, convex lenses separated by a distance, that's a compound microscope. The focal length and the aperture of the objective used is respectively the focal length and the aperture of the objective. Keep in mind, objective we are talking about. So this is the objective. This is the eyepiece. So this is objective. This is your eyepiece. The focal length of the objective and the aperture. Aperture is small. Yeah, aperture is small. And what about the focal length? What about the focal length? Come on. But actually, it depends on what you are comparing it with. In the compound microscope, the focal length and the aperture of the objective. So it really depends on what you are comparing it with. If you are thinking in absolute terms, the aperture should be large, but making it too large also doesn't make sense. So it is smaller as compared to the eyepiece. And focal length, yes, the object is kept very close so that the focal length is also generally very, very small. FO is small, guys. The focal length is very, very small. So yes, small and small. D option. Yeah, short and small. Actually, the wording should have been short and small. Okay, or else small and small is also fine. But yeah, it is small and small. Not an issue. Moving on to the next one on your screen. A microscope is focused on an object at the bottom of a bucket. Microscope is focused at the object which is at the bottom of a bucket. Some liquid is poured. Then what will happen? The microscope has to be raised. So question is, how much will you raise it by? See, I'll tell you, there is this microscope. You are raising it by some distance. Let's say like this. Earlier, the rays of the microscope were focused on this particular object. Now, it will be focused in the same way, but what is the difference is the moment you pour that liquid, you are focusing it on the image. That's the catch. So you have poured some liquid. So because of which there is an image which is formed, and that is why you had to shift it. And that is why you had to shift it. You're not changing the settings, you're just directly shifting it so that now you're focusing on the image of that particular object. So basically, question is, if the shift is already given, what is the height of the liquid? So the shift is nothing but the height into 1 minus 1 by mu, direct apparent shift formula. So the shift is 30. Height, I do not know. 1 minus 1 by refractive index, which is 5 by 3. So this will become 3 by 5. So it will become 2 by 5. H is 30. So multiply this 30 multiplied by 5 divided by 2. So it will become 15 multiplied by 5, which is 75. So 75 is C option, absolutely correct. So you have filled the liquid till some height. So because of which everything gets shifted. Got it? Amazing, amazing. Apparent depth concept. Cool. Very nice. Many of you have got it. Amazing. Let's go to the next question then. Shall we? Okay, perfect. Here comes the next question on your screen. The length of a microscope tube for compound 1 is 15 centimeters. Magnifying power for a relaxed eye is 25. Focal length of the eye lens is 6. And the object distance for the objective lens will be, okay, there is no option but to solve it properly. There is no direct, formula that will give you the answer. So start drawing it. No other option, guys. This is one lens. This is the eyepiece lens. Okay, so let us also show the principal axis here. Okay, so this is where your eye will be, basically. The magnifying power for relaxed eye. Now this is the catch. When you are saying the eye is relaxed, when you are saying the eye is relaxed, that means where is the image formed? Your eye strain when the object is very close, and the closest possible is 25 centimeters, least distance of distinct vision. Strained eyes, ciliary muscles are getting strained. The ciliary muscles of your eye will be very relaxed when you take the object very far. So your eyes are focused on a large distance. So that means the image is at infinity. The image is at infinity. Okay. Thank you, Gopal Krishna. Means a lot. Thank you so much. Thank you so much. So, if the image is at infinity, think where will the object be for the eyepiece? This image is infinity for your eyepiece. For your eyepiece, we are talking about for eyepiece. So, the object will be at focal point. Will be at focal point. So, I know this is my eyepiece. This is my objective. So naturally, somewhere over here, this is where the object should be. Only then the image will be formed at infinity. Now, what is the focal length of the eyepiece? It is already mentioned that the focal length of the eyepiece is 6 centimeters. So this is focal point of the eyepiece. This is your FE, and this is basically 6 centimeters. It is clearly mentioned over here. The length of the tube of the microscope is mentioned. That means this is mentioned as 15 centimeters. This is what the length of the tube means, distance between those two lenses. So from that, we can figure out how much is this distance, because although it is an object for the eyepiece with the image at infinity, that object is actually an image for the objective. It's an image of the objective which acts like object for the next refraction. And this image is coming from the object, the real actual object for that objective right over here. So this distance is obviously 15 minus 6, which is nothing, 9 centimeters. So 9 centimeters is nothing but your image distance for the objective. Is nothing but your image distance for the objective. I need that for the object distance. I need that for the object distance for the objective as well. Only then we can figure out the things. Yeah, what is that? The object distance for the objective. Yeah, only then we can figure out. Yeah. So what do I do now? Magnifying power formula is given, man. Just use that. What is the magnifying power formula for normal vision? For normal vision, it is magnification of the objective, which is nothing but V naught by U naught multiplied by for a simple microscope, it is 1 plus D by F. If it is distinct vision, for normal vision, it was D by F. Exactly, very similar formula. Yeah, exactly, very similar formula. Just put over here D divided by focal length of the eyepiece. That's all. That is the answer. So this is 25. Focal length is 6. Then what else is there? Magnifying power is how much? 25 is already given to me. And the only thing remaining is this is 9. This is UO. So solve this and tell me how much is the value of UO. UO will be, oh, by the way, 25 gets cancelled. And I'm just left with 9 by 6, which is 3 cancel, 3 by 2. So it is 1.5 centimeters, which is B option. That's all. So this formula, if you know, you get it. If it is normal vision, it is d by f. If it is given, it is not relaxed, it is strained, then it will be 1 plus d by f. That's all. Instead of multiplying it by d by f, you will be multiplying it with 1 plus d by f. That's the change in the formula. Understood? So these kind of questions can come. There is also a good question in your NCRT. Please do it. NCRT for compound microscope. We have done it in the class. If you want, you can even watch my NCRT classes, guys, on the channel. Big marathons I have done. Yo, where is it, man? Home. Go. Does money give you seat in IIT? Watch this shot, guys. I made this shot for all of you. Okay? Can money buy you a seat? You already know the answer, but you will be shocked to know something. This is your CBSE related marathons. I have made marathons for all of you. Current, electricity, electrostatic charges, moving charges, magnetism, all these things. Okay? So one by one, this is a big playlist. I can't move it here, but yeah, you can watch it. All right. So this is your entire playlist. Okay. So I think I should add other chapters also. Maybe it is not added. I'll complete that playlist. I think some videos are missing, but you can always do a YouTube search. You will get my videos. Okay, cool. Let's go to the next question coming up on your screen. Why do you think an astronomical telescope has a large aperture? Astronomical telescope, why do you think it has a large aperture, guys? Why? Because it will collect more light, number one. Number two, resolution. Diffraction effects are less. So it increases the span, large wavelength, has low dispersion, no, has high resolution. Else, if it is a small aperture, for a small opening, the rays get diffracted and you will not get a crystal clear image. It will not be resolved. So yes, it is not to increase the span of observation. No, it is not for that. You still want to focus on a particular part only. See, just because you have a big aperture does not mean you will capture more stars and more, planets. No, that is not really the thing. It's just that more light will come from those stars or whatever planet. The uh, idea is that whatever rays are coming, it should not diffract, because diffraction is a very dangerous phenomena in such optical instruments. Keep that in mind. Okay, because it will not give clearly resolved images. Focal length of an objective is given. Under normal adjustment, length of the telescope is given. Focal length of the eyepiece. This is direct, no? The length of a telescope is directly f naught plus fe. The focal length of the eyepiece is asked. Focal length of the objective is given 1.5. So length of the telescope is 1.56. So eyepiece focal length is 1.56 minus 1.5, which is 0.06 meters, which is option A directly. So the length of the tube is both their focal lengths of the objective and the eyepiece being added. That's it. Option A. Very good, Chandru. Sabrina, Dharni. Yes, Gungan. Yes, Gungun. Very good. Lewis, Sibi, Janani. Awesome. Very nice. Awesome, guys. Let's move to another question coming up on your screen before we resume the class for a break. Okay. So, in a normal adjustment for a telescope, objective and eyepiece distance is given. So, this is basically the length of the tube. This is the length of the tube. Focal length of the objective when the angular magnification of the telescope is 2. Oh, they have not given FO or FE, they have given the magnification. Now, magnifying power is nothing but F naught by FE, and that is given to be 2. So, basically, 2 is F naught by FE. So, F naught is basically 2 times of FE. Now we all know F naught plus Fe is the length of the tube, which is 30. F naught is 2 times of Fe from here plus your Fe. So 3 times of Fe is 30. So therefore Fe will be 10 centimeters, focal length of the objective they asked. So that means focal length of the objective will be 2 times of Fe. So 2 times of 10. So that means it will be 20 centimeters. 20 centimeters is option A. There you go. Cool. Yeah, simple, straightforward. So now we are going to resume for a break. I had planned for 11 o'clock. So I think we'll change the time to maybe we will meet at, what is the time now? 11:10, is it? Okay, we'll meet at 11:30. Okay, 11:30 we'll meet and we'll continue the session. All right, see you in a bit. Okay, so welcome back to the 69 questions from ray wave, optical instruments, and EM waves. Before the break, we have done ray optics and optical instruments, amazing questions. And now it's time to do the 36th question. We have done 35 questions till now. And the next set of questions, guys, it's going to be on electromagnetic waves and light waves. We'll start with light waves first, interference, then your Young's double slit experiment, single slit diffraction, and polarization. These are the topics under light waves. I had conducted a beautiful long marathon just a couple of days back. If you have not yet watched it, please check it out for all the aspirants who want a detailed theory plus concept application. So let's begin. And Harni is back. Pritija, nice to see you. And I saw all your comments, Pritija. Lovely comments. Thank you so much. Hi, Sabri. Welcome back. Welcome back, CB. Welcome back, everyone. Okay, great. Sir, sometimes I feel like, can I play odd? Can I play for, can I play COD? Oh, not odd. COD. Can I play for some time? Yeah, man, you can play. I mean, it's not a big deal. See, right now I have all the money. I have all the opportunity to play, all that freedom to play whatever games I want. I have very nice computers. I have very nice, system. But still, somehow I don't find that time to, play. I love to play nice games. I want to play COD. I want to play PUBG. I want to play, you know, NFS. I want to play Forza. I want to play Age of Empires. I want to play all these games. But unfortunately, no time because I feel while I was studying, I had more time. Now, as a teacher, I have very little time. Yeah. So when you have the chance as a kid, play it, but in limits, but not during the exam time. Not for 2026. Abhijit is our school kid. Okay, he's not 11th or 12th. He's in 8th standard or 9th standard now. So that is okay. Hmm. All right. So play, guys, but in limits. Don't let it become addiction because this is your age to play. When else will you play? Isn't it? You should know what has to be done, how much. Hi Vikshita, good morning. Hi Chandru, hi Pavi, good morning. Harni, what is COD? Oh, that's Call of Duty. It's a game. Hmm. All right. So, how many of you play games over here? And which games are your favorite? Let me know. Or if you're not fond of games, just put up a sad emoji. You're not playing games or not fond of games, sir. I'm fond of Instagram, sir, or I'm fond of Snapchat, sir. I'm fond of some weird app. I don't play games. Yeah, it's a game. Call of Duty. Thank you. Thank you. Oh, you're also from Salem. Wow. எப்படி இருக்குங்க? Brain New Ideas 2778. Oh, nice. Nice to see you. I was so confused. Abhijit was like waiting for the confirmation. Shreyas sir told. Now I'm going to show this video to my parents. See, Shreyas sir told I can play COD. So, Abhijit, please don't misuse my dialogue, okay? I'm just telling you, you play in limits to your parents also. Yeah. Zero gaming time, zero digital scroll. Very good. I love it. I love it. And every 12th standard student should say this because for you, every minute that you have should be utilized for getting into IIT. Once you get into IIT, do whatever you want. Yeah. In fact, you have so many opportunities. Just this year. Oh, near your district, Perambara. Oh, Perambalur. Okay. Okay. Nice. Nice. Chandru also from Tamil Nadu. Wow. We have lot of Telugu audience and Tamil audience. I'm really super duper proud of all of you guys out here. Great, great. So let's begin the class. And coming up on your screen, two coherent waves of intensities I1 and I2 are passing through a region at the same time in the same direction. The not ratio, sum of maximum to minimum intensities is. Whenever you have coherent sources and they interfere, constructively it produces maximum intensity. And the intensity is given by I1 plus I2 plus, not minus, and you will have 2 times root I1 I2. That's maximum. And this comes actually from the expansion of this formula. There is a direct formula, root I1 plus root I2 whole square. This is actually the formula. When they interfere destructively, you will get the least intensity, and the formula is root I1 minus root I2. Now the question is not on the ratio, rather their addition. So if I add I max and I minimum, it's kind of obvious that a plus b whole square, a minus b whole square will have a 2ab term here and negative 2ab term here. Those terms will cancel out. So what will add is root I1 square plus root I2 square plus this, what is that? Root I1 square plus root I2 square, because I know 2 root I1 I2 will cancel out with 2 root I1 I2 from that negative term. So this is nothing but I1 plus I2 plus I1 plus I2. So that is 2 times of I1 plus I2. That's all. So 2 times of I1 plus I2 is this B option. That's it. The other terms have got cancelled out. B for yes, your IIT Bombay. Amazing, guys. Moving on to the next question on your screen. Two monochromatic light beams have intensities in the ratio 1:9, and interference pattern is obtained by these beams. The ratio of the maximum to minimum intensity is. Okay, let's do this. If I try to find the maximum intensity, same formula, root I1 plus the second one is 9 times intensity. So this is what it will be. So this will become root of I plus 3 root I, because root of 9 is 3. 1 plus 3 is 4. So 4 root I whole square, which is 16 times of I. That is the maximum intensity which you can get. Similarly, minimum intensity which you can get is root I1 minus root I2. So it will just become root of I minus 3 root of I whole square, and 1 minus 3 is negative 2. So minus 2 root I whole square, but negative square is positive, so 2 square is 4. So 4 times of I. That's what it is. Now the question is on the ratio part. So the ratio of the maximum to the minimum intensity is 16I divided by 4I, which is 4:1. So 4:1 is again B for IIT Bombay. Cool? Yeah. Very good. Very good. Very good. Amazing, guys. Let's move to another question, because questions on intensities are very common in your interference light waves chapter. And by the way, this same logic is even applicable for sound waves or even for waves on a string. Okay, it's the same concept. If you take an interference pattern with two coherent light sources, intensity ratio 9:1, then they have asked Imax plus Imin, Imax minus Imin. I feel you can take this up as homework now, because already we did the same question 1:9, same thing, but they have asked Imax plus Imin ratio with Imax minus Imin. I think you can easily do this. Solve this as homework, answer it in the comment section. So many homework questions I'm giving because they are similar in nature, and you can see they are repeated models again and again. Okay, we'll not do that right now over here. Next one. In Young's double slit experiment with monochromatic light, you are seeing that maximum intensity is 4 times the minimum intensity in the interference pattern. What is the actual ratio of the intensities of the two interfering waves? Okay, so we all know, if you take the ratio of the max to the minimum intensity, it should be nothing but root I1 plus root I2 whole square divided by root I1 minus root I2 whole square. Is that right? The ratio of that maximum to minimum is given. So that is 4/1. So that is 4:1. And I can take a common square of root I1 plus root I2 divided by root I1 minus root I2 whole square. Take square root on both sides. So you will get square root I1 plus square root I2 by square root I1 minus square root I2. Square root of 4 is 2. So 2/1, of course. Now use the property of componendo dividendo. So if you use componendo dividendo property, so a plus b by a minus b is a plus b by a minus b on both sides. If you do numerator plus denominator upon numerator minus the denominator, So when you add the numerator and denominator over here, I2 and root I2 will get cancelled. So it will just give me 2 times of root I1. And when you subtract these two, this minus this, root I1 will get cancelled and negative negative will become positive. So it will become 2 times of root I2. Here it will become 2 plus 1, numerator plus denominator, numerator minus denominator. 2 will cancel. So root of I1 by I2 will be 3 by 1. Square both sides. So I1 by I2 will be 3 square, which is 9, by 1 square, which is 1. So 9 is to 1 or 1 is to 9, you can say. So what is the ratio of the intensity? 1 by 9 or 9 is to 1. There you go. Is that clear, everyone? Pakka? So these kind of questions are very, very common, guys. Wow, HV laptop, now you're in 10th grade watching a 12th standard class. Kudos. Okay, you didn't study 9. Okay, I will uh, help you out, HP laptop, but hold on for now because I am in a flow of a particular session. Maybe you can put a comment, or towards the end of the class, if you ask me, I will help you out. Okay, I don't want to break the flow now. Okay, so moving on to the next question. Here it is. Width of one of the two slits in a YDSE setup is half of the other slit. What's the ratio of the maximum to minimum intensity? What difference does the width of the slit make? See, if let's say, for example, this is your slit versus this is your slit. Okay, the rest of it is, you can say, opaque on this side, this versus this. What happens is when you increase the width of the slit, more light will come out of it. As simple as that. Here, if this much light was coming out of it, here more amount of light will come. So the intensity of the light is directly proportional to the width of the slit opening, width of that slit which is opening. So more light will come out of that particular slit. As simple as that. It's a double slit experiment. There are two slits, so there will be more light accordingly depending on whichever slit is wider. So if one of the slit is half of the other slit, that means the intensities are in the ratio of 1 is to 2. So it's very clear now. The ratio of intensities I1 is to I2 is basically 2 is to 1. The second slit is half as the first one. So intensity is also 1 as compared to 2. It's half. So question is, what is the ratio of the maximum to minimum intensity? So here again, I max by I minimum. I max is for constructive, I minimum is for destructive. It is the root of I1 plus the root of I2. Here it is 2I upon the root of I1 minus the root of I2, and this square, and of course this square. So what will happen is root I will get cancelled. So root of 1 is just 1 plus root 2 upon 1 minus root 2, this squared, and of course this squared. So what is a plus b whole square? A square plus b square plus 2 times a into b. A minus b whole square is a square plus b square minus 2ab, which is 2 root 2. So 1 plus 2 is basically 3. So 3 plus 2 root 2 upon 3 minus 2 root 2. So 3 plus 2 root 2 upon 3 minus 2 root 2 is the D option. Absolutely correct. So using this concept, the ratios are 1 is to 2 ratio. So I1 is I, so I2 will be 2 times or basically double of it. That's all. Option D. Cool. So use simple logic, guys. Use, simplifications. Don't sit and put, sir, I will put I1, then I will put I2, and then I'll put I2 as I1 by 2. It will unnecessarily complicate the mathematics. Why do you want to do that? Okay, perfect. Let's go to the next one on your screen, and here it is. In YDSE experiment, a monochromatic light is used. The fringe width obtained is 1 millimeter. Fringe width is 1 millimeter. Wavelength is half. Slit width is double. Actually, it should not be slit width. The distance between the actually, maybe it is that only. slit width is doubled, what will be the new fringe width? Okay, it's a good question actually. See, fringe width is wavelength into distance between screen and the slits upon distance between the slits. In this question, it is clearly mentioned that your wavelength has been halved, capital D unchanged. Lot of people think slit width means D. That is wrong. D has not been changed. Actually, only then beta will change. It will just become half times because RHS is half. LHS will also be half. So it will be half of a millimeter. Half of a millimeter is 0.5 millimeter. Hence, the answer is simply 0.5 millimeters. Is this clear, guys? Is this absolutely clear, everyone? Here, a lot of people think that my slit width has been doubled, so this will become double, so beta will become 1/4. No. See, this is one slit, this is another slit. Okay, this distance is small d. That has not been changed. When I say slit width is doubled, most likely this is what has happened. So now the slit has become extra wide like this. So this is the width of the slit. This is the width of the slit. It has become more wider, but the distance between the slits is still going to be the same. Got it? Hence the answer is 0.5 millimeter. Common mistake. Many kids are going to mark B option. Many kids. I know this. See, I already expected it and already you did it. Hai na? So these are things which you should be very, very careful about. Okay. Next one. In YDSE experiment, slits are separated by 0.2 millimeters. Slit separation is increased to 0.4. Slit separation, which is actually small d. Then the percentage change in the fringe width is how much? Fringe width is lambda capital D by small d. If you notice, earlier the separation was 0.2, now it has become 0.4. So D has been made 2 times. So if somebody makes this value 2 times, this means that entire ratio has been made half times on the RHS. That means the fringe width is nothing but made half times. But half times means, if it was 100, now it has become 50. So therefore, 50% reduction, reduced. So it has been reduced by, fringe width has been reduced by 50%, which is B option. Got it? Clear? Very direct kind of thing. Yeah. Yes, here it is distance between the slits. So I am warning you again, do not get confused between the width of a slit versus distance between the slits. I'll repeat carefully, understand. This D will only affect fringe width. The width of a slit, the width of a slit will only affect the intensity. So they have two different effects. The distance between the slits affects the fringe width, but the width of a slit will only affect the intensity of light. So be very, very careful. You can put it in your notes, in your flashcards, whatever you guys are using, or else you will not remember it when you are doing that mistake again. That will pinpoint it. See, bro, I had already written it down, still you are making that mistake. So you should have a mistake log. In YDSE experiment, the ratio of the phase difference between the light waves reaching the third bright fringe versus the third dark fringe. Phase difference for bright and dark fringes. See, there are mathematical or formula ways of doing it which I don't really appreciate because it will unnecessarily confuse you, because you will have to remember n2n lambda, the 2n pi, or 2n plus 1 or 2n minus 1, where n starts from 0 or whether it starts from 1. How does the numbering begin? All those things are going to confuse you. In that exam, 100% you are bound to make mistakes. Rather, what you do is, take this screen. This is your central line. Okay, this is your central maxima. So wherever you reach central maxima, the phase difference will be 0 pi. Then the next bright fringe will be happening at 2 pi. Next bright fringe will be happening at 4 pi. Next bright fringe will be happening at 6 pi, like that. So these are basically your bright fringes. First bright, this will be your second bright. We are talking about the third bright, right? So this is your third bright fringe. 6 pi is the phase difference. Always constructive interference, maximum intensity, maxima, bright fringes, all of them mean the same thing, and they all happen at even multiples of pi. 0 radians, 2 pi radians, 4 pi radians, because they will be in phase, the phasors, so that they give maximum constructive interference. Whereas for destructive interference, it will be at odd multiples of pi, like 1 pi, then you have 3 pi exactly in between of them, then you have 5 pi, and so on and so forth. This will be your first dark fringe. This will be your second dark fringe. We are talking about third dark fringe. So this will be your third dark fringe. Now, from here only you get the answer, guys. The question is ratio of phase difference of third bright and third dark. This is third bright. This is your third dark. So it will be 6 by 5. Very direct. Can you see how easy it is via this method? Else you have to chumma waste your energy, guys, in mathematical form. Yeah. No, these are not PYQs. Cool. Everyone understanding? If a similar thing was asked for wavelength, path difference, that is, then how will your number line look like? Let me remind you. How will your number line look like? So for your central maxima, it will be 0 lambda. For first maxima or first bright fringe, it will be 1 lambda, then it will be 2 lambda, and then it will be 3 lambda. That's how it goes. For dark fringes, exactly half of it, 0.5 lambda, then 1.5 lambda, then 2.5 lambda. Remember, this is odd multiples of lambda by 2. This is 1 times of lambda by 2. This is 3 times of lambda by 2. This is 5 times of lambda by 2. Like that. So this is for path difference, this is for phase difference. It's very easy to make it. Within seconds, you will get the answer. There is no confusion when you do it like that. And nobody is going to ask you 1057th bright fringe versus 789th dark fringe. Nobody is going to ask you like that. Okay, they will ask you like 5th, 6th maximum, not more than that. Okay, there we go to the next one on your screen. In YDSE setup, the nth bright of red, nth bright for red coincides with n plus 1th bright for violet, value of n if wavelengths are given. Okay, whenever coincidences occur, what happens is that, see, observe this. This is your screen. This is, let's say, your central maxima. Then, let's say, for example, these are the fringes of red, one by one. And let's say for violet also, you show it. So what happens is, if each of fringe width of the red color is beta r, like that there are n fringes of red. Similarly, each fringe of violet color is beta v. Like that there are n plus 1 fringes, of violet color. The total length will be the same. This total length that we are talking about, the y coordinate, will be the same, because that is where they essentially coincide. The bright fringes of both these things are coinciding, so their total length will be the same. So hence one can easily say y is numerically equal to, here we can put n times of fringe width of red, and here we can put basically n plus 1 times fringe width of violet. But wait a minute, fringe width is nothing but lambda capital D by small d. Here n plus 1 is as it is. And on this side you have lambda of red into capital D by small d. As you can notice, D and D will get cancelled. So you just have to substitute the values. N into lambda of red. Lambda of red is how much? 6300. It's the ratio, so don't have to convert it into anything. It will be n plus 1 into lambda of violet. Violet is 4200. Now just have to open up the brackets and solve this. 0, 0 cancels, and you have 63 times of n is equal to 42 times of n plus 42. Take this on this side. Everybody gets this till here? What we have done? Perfect. Okay. So what will this answer be, guys? Yeah. So this will be 63 minus 42, which is 21. N is equal to 42. So n will be equal to 2. So question is, what is the value of n? So A answer is the right one. N is 2. So the second right fringe is coinciding with the third violet fringe. That's the meaning of it. The second red fringe is coinciding with the third violet fringe. So this equation is always there, and these coincidence problems are very common and popular in the JEE Mains examination. You open up so many PYQs, you will see. Okay. So this model very, very crucial. Let's go to the next one coming up on your screen. In a YDSE setup, the light of wavelength lambda passes through a double slit and forms interference fringes on a screen 1.2 meters away. The difference between the third maxima and the third minima is this much. Then the slits are how this much apart, then lambda is how much. Okay, so I'll tell you what in this particular question. This is your screen, this is your central maxima, let's say. Then say for example, this is your third maxima, and let's say this is your second maxima somewhere here. In between of that, you will have your what is that? Third minima. 0, 1, 1. Okay. So this, let's say for example, is your third minima. This is your third maxima. This is your second maxima. Remember, between every two maximas, there is a minima. Between every two minimas, there is a maxima. They keep on going alternately. We already know the distance between a maxima to next maxima is the fringe width. So naturally, how much will this be? This is exactly half of it. So it will be beta by 2. And that value has been given to me. The difference between the third order maximum and third order minima, this value has been given to me. How much has it been given? This is given to be 0.18 centimeters. This has been given as 0.18 centimeters. This is actually beta by 2. How many of you get this? Exactly half of it. So just use that concept. Beta by 2 is 0.18 centimeters, but do not keep it in centimeters. It will be in meters. So minus 2. Beta is lambda capital D by small d. Lambda, I do not know. Capital D 1.2. Small d, distance between the slits is 0.02. So 0.02 into 10 to the power minus 4 and is equal to 0.18 multiplied by 10 to the power minus 2. So lambda will be, this will be 18 into 10 to the power minus 4 multiplied by 2 into 10 to the power minus 6, whole thing divided by, this is 12 into 10 to the power minus 1. Solve this and check out how much is the wavelength that you are getting. 2 goes with 12 6 times, 18 goes with 6 3 times. So the answer should be in 3 terms. So it should be, unless we have made a mistake. No, this should be 300, guys. Just check it out. This is 2 into 6 is 12. So 18 goes with 6 3 times. Yeah. So oh, I missed that 2. I'm so sorry, guys. That's why I got a wrong answer. 2 is there here. So 2 is there here also. So that 2 will multiply here also. So 6 will, sorry, 3 will come here. 3 2s are 6. So this should become 600 into 10 to the power minus 9 meters. That will make it 600 nanometers. So answer is C option, 600 nanometers. Perfect. There you go. So that's how you do this. I did not really calculate it. I just took care of the numbers. Remember, powers of 10, decimal places, zeros should never bother you in the calculations unless there are similar digits in the options. I just look at the numbers here. 2 cancels with 12 becomes 6. 2 cancels with 6 becomes 3. 18 divided by 3 is 6. So I should get 6 in the answer. I don't care about the powers of 10. So it has to be 600. Got it? Yeah. Yes, I had to multiply by half. I did it. Great. Moving on to the next question on your screen. Now, guys, ready for it? Come on, let's go, guys. Young's double slit experiment is first done in air and then in a medium of refractive index of mu if the seventh dark fringe in the medium lies where the fourth bright fringe is in air, the value of mu is. Slightly confusing statement, but we have to dissect it slowly. Okay. So the fourth bright fringe is in air. What's the formula for the location of a bright fringe in a YDSE setup? The formula is Y is equal to n times of basically lambda capital D by small d. Okay. All right. So n over here, we are talking about the fourth bright fringe. So 4 times lambda capital D by small d. This is all happening in air. This is all happening in air. And it coincides because it is given that lies where. That means this concept says that y is the same value. Y is the same value. Seventh dark fringe in that medium, which has refractive index mu. Now, it is also a dark fringe. So the y value for that is odd multiple of lambda in that medium, capital D divided by small d. This is the catch. It's an odd multiple of lambda prime. Remember, in that medium, wavelength will change. Speed of light will reduce. Wavelength will also reduce. So this lambda prime will be lambda by mu into d divided by small d. What do you think is that odd number going to be? What do you think is that odd number? Seventh dark fringe, guys. Seventh dark lambda capital D by small d. Lambda lambda d small d cancels. So we are just now left with 4 is equal to 13 by mu. Therefore, mu is equal to 13 by 4. 13 by 4, guys. Yes. 13 by 4. Oh, that number 2 was also there. I forgot that number 2 over here. Lambda d by 2d. So this, why am I forgetting 2 always? Just hold on. So 2 is there. So 2 will be there here also. And mu will be 13 by 8 then. Sorry, 13 by 8. Yeah. Come on. 1 point how much? 1 point close to 1.875, I think. Yes, 1.875, I feel. 1.875. Pakka? Yes, it is the correct answer. Yeah. Buffering. Refresh. I'll also refresh on my side. Just check if I'm visible, audible properly. Not matching. Is it matching now? Yeah, it is not 13 by 4, it is 13 by 8. 13 by 8, guys, not 13 by 4. The 2 was missing. It is always odd number by 2 times of lambda prime d by d. Okay, that whenever it is a dark fringe, it is a given thing, it is a dark fringe. So whenever dark fringe is there, odd number by 2 times lambda d by d. That's the formula. Now is it okay? Okay. Now all good. All right. Perfect. Yes. 13 by 8, 1 point. Did we make a calculation mistake? 13 by 8 is not 1.875, 1.625. Yes, you're right. And how come the answer marked is this? No, it is wrong. So I'll just redo it over here, guys. Sorry, just check this out. So for our dark fringe, y is odd number by 2, lambda prime d by d. Lambda prime will be lambda by mu, and this is capital D by small d. Odd number, seventh dark fringe, so 13, and by 2, of course, this is y. So it will be 13 by 2 lambda d by small d, and that mu will also come. The y is the same, so I can use the same y from here. So 4 lambda d by small d. So just check this out. Mu goes on the top, 13 is there, okay, and 4 twos are basically 8. Lambda lambda dd and small d also gets cancelled. So 13 by 8, guys, should be 1.625. 1.625. I think 1.625 is not there in the options, so I will have to remove these options. Maybe I can just make this option 1.625 close enough. That's all I can do. 1.625, and then this option will be correct in this if I make it 1.6. Yes. Yeah, the options are not matching. Correct. Okay, cool. Let's go to the next question on your screen. If YDSE setup is done with white light, which of the following will be true? If you use white color, it will have all the colors and wavelengths, violet also, red also, orange also, everything. So what will happen because of that? What will happen because of that? Every color will form its own fringe pattern. It will be all like a mixture, but one thing will happen for sure. On the center of the screen, all of them will form maxima together at once. So when all red, violet, indigo blue, all these colors will form their maximas on the center of the screen, all these colors will again recombine back and give back the original white color only at the center. Other than that, you will see a mixture of patterns everywhere. So all the bright fringes will be colored, all the central fringe will be white. It will be a stable pattern, it will be visible, but it will be a mixture of patterns. All the bright fringes won't be white because every bright fringe will be at a different place because of different colors, wavelengths. The bright fringes will be colored. All the bright fringes will be colored. What do you mean by that? All bright fringes are colored. All bright fringes will be just bright, man. I mean, like, what do you mean by colored? It could be of different colors. That's it. But it doesn't make much of a sense. So it is actually option C. Only the central bright fringe will be white in color. All right. Moving on to the next one. For Fraunhofer diffraction to occur, the light source should be where? Now, there are two kinds of diffractions. One is obviously your Fraunhofer. The other one is Fresnel's diffraction. This name is shorter. So, in that case, your source is closer to the slit to see the diffraction. Yeah, the source is basically very close to the slit. But for Fraunhofer, you will see that the light rays almost come parallelly and they fall into the slit before you see the interference pattern. So the light rays are coming from a very far away source before you see the pattern. How do I remember the difference between Fraunhofer and Fresnel? This name is longer, right? So it is coming from a long distance. Fresnel, very small name, so coming from a short distance. So the light source should be basically at infinity. And you will see the screen will be also very far to see the interference pattern. B for IIT Bombay. Correct. That's how you do it. Yes, a very large distance basically. Ideally, it should be infinite, but in reality, it is not infinite. It is a very large distance for real case, you can say. Cool. Moving to the next question on your screen on diffraction. There is a slit of a certain width 10 into 10 to the power negative 7 meters, which is illuminated by light of wavelength 500 nanometers. Angular position of the first minima. For the minima, the formula goes like this. Width of the slit into sine theta is nothing but n times of lambda. We are talking about the first minima. first minimum. So n is basically 1. Wavelength is given 500 nano, so into 10 to the power negative 9. The slit width is also given 10 multiplied by 10 to the power minus 7. Sine theta is not given, theta is asked. So from this, sine theta will be, this is 5 into 10 to the power minus 7 divided by 10 into 10 to the power minus 7. Minus 7 power cancel. 5 by 10 is half. So if sine theta is half, it's obvious that theta is nothing but 30 degrees. So option B is the right answer. A sine theta is n lambda is formula for your dark fringe. Yes, not for bright fringe. Okay, very good. Moving on to the next question on your screen. The wavelength of light which is used in single slit diffraction is this much. The width of the slit for which first minima appears at 45 degrees will be how much? It's a reverse question, same formula. So again, we are going to stick to A sine theta is n lambda. We are talking about first minima, so n is 1. Wavelength is 800 nano, so 10 to the power minus 9. A is asked, here angle is given, so it is sine of basically 45 degrees. So A will be 800 will become 8 into 10 to the power minus 7. Sine 45 is 1 by root 2. So on the other side, it will become root 2. So it will become 8 multiplied by 1.4 multiplied by 10 to the power minus 7. If you want, you can, see how much will it come out to be if you want to make it 10 to the power minus 6. So it will become 8 multiplied by 0.14 multiplied by 10 to the power minus 6 in meters. So this 10 to the power minus 6 will become micrometers, and 8 into 14, guys, approximately. Yeah, 112, but we can approximately say, because this is actually 1.414, so most likely it will come close to 113, so 1.13. So, actually it will be 112, but we are just approximating it to 113 and shift the two decimal places. So 1.13 should be the answer. This minus 6 power, I have made it micro. I have taken that minus 1 power here. So I've shifted the decimal to make it 0.14 because I saw the options was in micrometers. So let's see whether it is correct. Yes, it is option A, my dear warriors. Wow, very good, Chandru. Very good, Harni. Excellent, perfecto, Sabri. Amazing, amazing. Yes. Sir, what color will appear near the white central maxima? So what happens is the red fringe is the biggest fringe, right? So for that question where we solved this one, so you will see the red fringe will be the largest, then yellow will be medium, you can say, and violet will be the smallest. This is how it will be. Now, exactly at the center, all these colors are combining. So when all these colors combine together, in this part, you will see white, which is at the center, But the fringe will look like a combination of colors. The end part will look red, but by that time, it's quite possible that your violet fringe might start coinciding with it because your violet fringe will be here, correct? And on both the sides like this. And then your yellow fringe will come over here. Yellow will probably come over here like this. God knows. I'm just chumma drawing it randomly. And then maybe your red again will come over here. So you might see a mixture of colors here and then reddish it will become, but again it will start coinciding with some other colors. It will appear little reddish pinkish kind of thing, but you cannot really say for sure unless you practically put the values or practically do it. Okay, awesome. So let's do the next question. Yes, we did this. Yeah. In a single slit diffraction experiment, for a slit width of alpha, the width of the central maxima is beta. If we double the slit width, then what will happen to the width of the central maxima? Interesting. Awesome, KL Rishi, you understood it. Great. So what is the width of the central maxima? Central maxima has a width of nothing but, just like fringe width has a formula, same thing, lambda, distance between the screen and the slit. But here you have the slit width, not the distance between the slits, because there is only one slit. That A corresponds to the width of the slit, but there is a number 2 over here. Just keep that in mind. It's like your fringe width formula only, but with a number 2 for the central maximum. Okay, so this is the width of the central maxima. Now it is given the slit width is alpha, so I'll put alpha over here. Okay, so what have you done with the slit width? The slit width has been doubled. So if you make this 2 times, this entire ratio will become half times. So it will basically become beta by 2. Yes, beta by 2 is the answer. Yeah, it will become half times, isn't it? Cool. So you should know this formula. Sometimes they give you the value to be calculated. That's all. Yeah. Sometimes they can actually give you the value for the width to be calculated. Cool. Let's go to the next question on your screen. The relation between the polarizing angle and the critical angle. What is this polarizing angle? This polarizing angle is basically Brewster's angle. Is basically your Brewster's angle, meaning when you take light which is falling at certain angle, it will reflect, it will also refract. We should show it like this. Yeah, it will also refract. The refracted and the reflected light rays are perpendicular to each other, and this light is basically polarized. This is your incident light, which is unpolarized, unpolarized, unpolarized. Then this angle is called as your Brewster's angle. IP you can call it, IB you can call it, whatever you want to call it. This is your Brewster's angle. And remember, tan of Brewster's angle is actually the refractive index. What is that critical angle? That critical angle we are talking about is total internal reflection. And we know that in total internal reflection, sine of the critical angle is 1 by refractive index. So just put sine of theta c is 1 by refractive index is nothing but tan of IP over here. What has been asked? Tan of IP. Okay. So therefore, tan of IP will be 1 by sine theta. 1 by sine theta is nothing but cosec. So it will be cosec theta. Therefore, IP will be tan inverse of cosec theta c. That's the answer. Tan inverse of cosec theta c, which is first answer over here. Is that clear? So there were two different concepts. One was from refraction, ray optics, and this is from light waves, your polarization concept, Brewster's angle. And refracted and reflected rays are perpendicular, and Brewster's angle tan is the refractive index. Cool. Very nice question. Cool. Let's move to the next one coming up on your screen. There are two polarizers placed in such a way that their intensity of the light will be 0. This clearly suggests that first polarizer versus the next polarizer, they both are perpendicular to each other. Their axis, polarizing axis, they are nothing but perpendicular to each other. Only then this can happen. So P1 is basically perpendicular to P2. So what will happen is whatever light will go, so say for example, this is unpolarized light, I, this will become half and that will finally come out as nothing. But then you have kept a third polarizer in between, making some angle so that the intensity of the light passing through all of them finally is maximum. So you have taken a third polarizer, maybe kept at an angle over here like this. So that axis is making some angle, and this I call it as P3. Now P3, whatever, observe this, P3, whatever angle it might make over here with P1, with P2, it will make exactly the complementary angle, which is 90 minus theta, which is nothing but 90 minus theta. First things first, when this unpolarized light passes through the first polarizer, the intensity over here will be exactly half. So it will be I divided by 2. When it goes from P3, then use Malus law and you will see the intensity over here will be I by 2 cos square theta. Finally comes this polarizer. What will be the intensity? So this is the final intensity. Whatever intensity is falling onto it, cos square of the angle between the plane of light and the polarizing axis. So these two angle is 90 minus theta. Use Malus law. So I by 2 cos square theta into cos square 90 minus theta. Now that will become I by 2 cos square theta into sine square theta. So I can multiply it by 4 and divide by 4. So it will become I by 4 and into 2 will make it I by 8. Why am I doing this? It will become 2 sine theta cos theta whole square. Why I did this, you will understand in a bit. But first, understand the equality. 2 square is 4. 4 and 8 will cancel. You will still get the number 2 in the denominator. The reason of doing it is because this will turn into sine of double angle 2 theta and whole square. So if I want my final thing to be maximum, obviously this should be maximum, and this can only happen if 2 theta is 90, because sine maximum value is 1, so this will happen at 90 degree. So theta will be 45 degrees, something like we do in the range calculation for projectile. Similar terms come. So from there you get an idea. So theta is 45 degree, which is pi by 4 radians. 45 degrees or pi by 4 radians. It's a beautiful question. So every time what will happen when the light passes here, first it will get polarized in this direction. Then when it passes here, it will get polarized in this direction. And finally that light falls here. It will eventually come out like this. And this is the final light's plane of oscillation. Yeah, amazing. So time to start with electromagnetic waves. Are you ready for it? Which question were we on? We were on question number 53, guys. Last couple of questions. Question 54 on your screen. Here it comes. Time to go for 69 questions. I'm so glad, Gokul Raj, you are loving it. For quick revision, confidence boosting, and we need more sessions like this. Guys, how about taking entire 11th standard syllabus you want, or do you want me to conduct one more marathon, or shall we do mock test? 11th mock test, 12th mock test, and then a full syllabus mock test. And I'll also take one day, I'll dedicate for complete physics revision, maybe 11 hours or 12 hours session. We'll do that. Do you want to take a mock test first? Because I feel that will give you some idea about how the question papers will be, and it will push you towards exam strategies. Yeah, maybe we can conduct some 2 or 3 mock tests and then we can take a full revision. Yeah, because it will be January now. Because this year's final academic session by your captain Shreyas is today. After this, I think Diksha ma'am's class or Namrata ma'am's class is there, and New Year's Day we are not taking any class. Even on first, it is holiday, and one day I want to take holiday, guys. It's been a long time. So from 2nd Jan again I will take class. But it's not like I will not see you. I will be taking small classes, but not marathon. Okay, just that 1 or 2 days I'll be spending little bit of time with my family also. All right, cool. Another physics marathon on electrostatics, temperature, thermal properties. Okay, I'll plan for that maybe. Okay, fine. Let me see what I can do. All right, mock test. Many of you want mock test. I know many of you would be interested in the mock test also. And let me see if I can simultaneously, maybe in the morning time. Tell me one thing, your schools and colleges are done, right now. You don't have to go to schools and colleges now. Like, it's bare minimum, namesake, or only for some pre-board activity or some basic activity will be going. So I think you will be free now in the month of January in the morning time. So we should start keeping morning classes now. 11 o'clock, 10 o'clock. I think it is wonderful. You will utilize it, and maybe we can do some units of thermal and fluids or electromagnetism. Cool. Please don't take classes on NY and NYE. Man, XD lol. You're too advanced, bro, in your lingo. I was thinking, what is NY and NYE? New Year's evening and New Year's. What is NY? New Year's. It's the same, no? Or you're telling the first day of New Year. Okay, don't worry. I will not. After 6 Jan, I am free. Board practical. Ayyo. At home dropper, best thing. Practicals is there. You chill, man. Practicals will keep on going. You don't have to waste too much time. It will happen. You will pass. They will give you, out of 20 marks, they will give you 18 marks or 19 marks at least. They can't give you 15 marks unless you are in a very cruel college or school and you have done something really big mistake somewhere. Okay. The source of electromagnetic waves can be moving with constant velocity, circular orbit at rest, moving parallel to the magnetic field. No. See, accelerated charged particles by Maxwell's radiation emit electromagnetic radiation. So, accelerated like circular orbit. Remember, in fact, this was one of the drawback of Rutherford's model in atomic structure. When an electron is revolving in a circular orbit, it is an accelerated charged particle. So it should emit electromagnetic radiation and it should lose all the energy and fall into the nucleus and collapse instantly. But Bohr's model modified and said that no, not every time, only in certain orbits you will see that energy cannot go out and it will be trapped in there in the form of standing waves. So, those orbits are called stable orbits where no electromagnetic radiation occurs. Okay. So that was Bohr's model, overpowering your Rutherford's model. So from there, you can get an idea. It should be a circular orbit. Any accelerated charge particle, basically. Yeah. Cool. Paka. Done. Dusted. Let's go to the next one on your screen. Here it comes. A light of frequency traveling through air is incident on a medium of refractive index 2. What is the wavelength of the refracted light? The logic for this is because the speed of light will be speed of light in vacuum divided by mu. Same way, the speed of light, wavelength of light in the medium will be wavelength of light in air divided by refractive index. But remember, this lambda is nothing but that speed in air upon the frequency, speed in speed in vacuum divided by frequency. So this is what you should get, C by F mu. Okay, how I got this is because C is equal to F times of lambda. So lambda will be C by F. Okay, so this was all for air. So now you just have to substitute the values. Speed of light in air is 3 into 10 to the power 8. Frequency 5 into 10 to the power, what's that, 14. Refractive index 2. 5 2s are 10. So this will become 10 to the power 15. So it will become 3 into 10 to the power 8 divided by 10 to the power 15. So what will it become? 300 into 10 to the power, how much? Minus 9 meters, which is 300 nanometers. Just check this out. Just check this out, everyone. Yeah, answer is B, guys. Perfecto. Amazing. I mean, it had to become on 3. The moment I got 3, no, I knew the answer will be 300. I don't have to waste time calculating the decimal places. Yeah, simple. Awesome. Please, sir. Sir, I am a PCB student willing to write IIT 2026. Give advice for maths. Oh, a lot of students for IIT too. Okay, I'll definitely help you out, guys. Last year also we did IIT sessions. We also did UGEE sessions on the channel. So, all the top exams, because I'm telling you, none of the channels are concentrating. Very few channels are there. There are good channels, but very few are actually thinking about South Indian students, Northeast students, metro students who want to learn in English. And many Hindi channels also don't conduct classes for UGEE or IIT, or even for BITSAT for that matter. English, logical reasoning, all these are very important. So we'll be doing it over here. Don't worry. Even for Amrita, even for VIT even for SRMJ. These are all exams which you will be giving at the end of the day. Okay, don't worry, I'll help you out. Next question on your screen, here it comes. If you have an EM wave which strikes at 45 degrees in air on a liquid, and when it goes into the liquid, it gets deviated by 15 degrees. What is the speed of the wave in the liquid? If the speed of the wave in air is this much, it's simple only. I'll tell you what. Unnecessary big statement and all they have given. This is by Snell's law sine of I divided by sine of R. And that is also nothing but speed in vacuum on speed in the medium. Now, speed in vacuum is already given 3 into 10 to the power 8. Speed in that medium is what is not known. Angle of incidence is already given. See, you can think of it like this. This is that medium. This is that light ray which came and it got deviated like this. That right? This is that perpendicular right over here. So if this is nothing, makes an angle 45 degrees with the vertical traveling in air strikes horizontal. Yo, what is this? This is 45 degrees. Okay. And it gets deviated by 15 degrees. That means this angle is nothing but 30 degrees. It's obvious. So this is your refracted angle. This is your incident angle. So this is nothing but sine of 45 divided by sine of 30. Sine 45 is 1 by root 2. Sine 30 is 1 by 2. This is 3 into 10 to the power 8. And this is V. So 1 by root 2, 1 by 2, 2 goes on the top by root 2, which is again root 2, is 3 into 10 to the power 8 divided by V. So V will be 3 divided by root 2 into 10 to the power 8. 3 divided by root 2. Now root 2 value 1.414. So 3 divided by 1.5 will be 2. So 3 divided by 1 by root 2 will be 2 point something, 2.1 or something. So I think it should be this option. Yeah. So how do I get it? See, 3 divided by root 2. Root 2 is 1.4. So into 10 to the power 8. Now, if this number was 1.5, this will be exactly 2:1 ratio. So because the denominator is smaller than 1.5, so this ratio should be slightly more than 2. So slightly more is 2.1, not 2.5. 2.5 is, higher by a larger margin. So hence 2.1. Cool. Let's go to the next one on your screen. Which of the following have zero average value in a plane electromagnetic wave? Zero value. Electric magnetic field both or magnetic energy. Gravitation, we can take it up with electrostatics only. No need to take it separately. Captain sir, we want sure shot NCERT exercise questions for 12th physics board. Yes, Amrit, I will be taking board classes for all of you after the JEE Mains, immediately. Okay, we'll only focus on board preparation, CBSE, for that 2-3 weeks. Okay, don't worry, that entire February month will go in your board preparation. But simultaneously, I'll be also taking care of 11th standard students. A lot of 11th kids are there with a lot of backlogs. Don't worry, and there, yeah, we'll do something for all of you because I know you guys have been waiting till December. We did sessions. Now your turn will come in 2027, guys. Yeah, and 10th kids, if you're watching this video, something amazing also coming for you because Captain Shreyas sir is planning things for all of you. 10th moving 11th. Yeah, both electric and magnetic fields. Yes, that's the correct answer because it's a sine wave now. So whatever positivity will come will be the same as the negativity. So the average will be obviously 0 because the total area is 0. So the average value will be obviously 0. So hence it is both A and C. Moving to the next question. Select the wrong statement of the following. Wrong. Electromagnetic waves do not require any medium for propagation. Correct. Electromagnetic waves can travel through vacuum at the speed of light. Correct. Material medium is necessary for no. Electromagnetic waves are transverse. Yes, that's why they can be polarized. So C option is the wrong answer. Perfecto. How many of you gave C? Very good, Gungun. See, because yeah, they're sine waves, cosine waves. Yes, their average values are always going to be 0. Correct. Let's go to the next one. The ratio of amplitude of the magnetic field to the amplitude of the electric field is reciprocal, speed, proportional to frequency, inversely proportional to the frequency. Ratio of the amplitude of the magnetic field upon the amplitude of the electric field. Guys, isn't this 1 by C? Because since E naught by B naught, remember standard formula was speed of light. So the reciprocal of speed of light. So the reciprocal of the speed of light in vacuum, just option A. I mean, if you give it, only J PYQs in all the modern physics. No, these are not PYQs, Varshit. These are non-PYQs. PYQ models are there. Some might look like PYQs, some might look very familiar, some might be exactly PYQs, but keeping as much as possible non-PYQs model. Okay, right. Moving on to the next one. The ratio of the magnitude of the electric field to the magnetic field of EM wave is of the order. Electric field magnitude by magnetic field magnitude is always speed of light. So 3 into 10 to the power 8. So the answer will be nothing but D. Yeah. Same thing, they have rephrased it. Nothing else. Very good. Next one. There is a EM wave. Frequency is given. Particular point. Magnetic field is given. What is the electric field at that point? We know electric field by magnetic field is speed of light. So electric field will be magnetic field into speed of light. Magnetic field is 2 into 10 to the power minus 8. Speed of light is 3 into 10 to the power plus 8. So minus 8 plus 8 cancels. 2 3s are 6. So 6 volt per meter should be the answer. One might figure out that why is this given? This is completely to be ignored. It's irrelevant to the problem. Chumba to confuse you. Often it happens, you are always wondering, why is this given? Sir, I didn't use this value. I thought I went wrong. I kept on rechecking. I was thinking it will depend on this. But then I understood, oh, it was such a waste of time. So sometimes they will unnecessarily give waste data, redundant data, which is completely useless. Next one. If E and B represent magnetic field and electric field vectors, then the direction of the wave propagation. I had told you, electric field, magnetic field and velocity of light are mutually perpendicular like your IJK unit vectors. So always electric field unit vector into magnetic field unit vector is the speed of light unit vector. So E cross B will give you the direction of which the direction in which the light will propagate. So it should be E cross B. Yes, very good, very good, very good. Next one on your screen now. If E and B fields are given and it is clearly mentioned the light wave is propagating along z-axis. If light is propagating along z-axis means C is k cap. So how can you get C? Think about it. Because C cap is nothing but E cross B. Is nothing but E cross B. So if I want K, E should be I cap, B should be J cap. So this E should be along x-axis. So you should probably have x, and B should be along y-axis. EX and BY. EX and BY, or I and J. I and J. I and J is only there in one option, which is A option, nothing else, as you can see. E is I cap, B is J cap. So that's all. Two components can give you speed of light in the Z direction. Very nice, guys. Proud of all of you. Moving on to the next question. In an electromagnetic wave of certain frequency, which is going in the x direction, the electric field vector is 6. Then what is the magnetic field vector? I think it's doable now. Very easy. Electric field by magnetic field is speed of light. So magnetic field is E by C. Electric field is 6. Speed of light is 3 into 10 to the power 8. 6 by 3 is 2. So 2 into 10 to the power minus 8. So 2 into 10 to the power minus 8 is option A. It's, I think, the reverse of the previous question only. I think it got just repeated. Yeah, it's just the same thing, just in the reverse way. How? Okay. Electromagnetic wave questions are usually simple only. Very rare they can give you questions like this, and that is electric field equation is given and they ask you magnetic field equation. That is the toughest question which is usually going to come in your EM waves chapter. Other than that, they give you questions on finding refractive index or finding the speed of light, relative permittivity, relative permeability is given, E is given, B is asked, directions are given, comparison of wavelengths, frequencies, applications of those electromagnetic waves. It's a very simple, sweet chapter, guys. Okay. And obviously the starting part, origins of electromagnetic waves, moving charges or changing electric fields, creating electromagnetic waves. That's the entire of chapter. If you have an EM wave traveling in X with field equation given by this, the correct expression for magnetic field. If it's sine, it should be sine. If it's kx minus omega t, it should be kx minus omega t. Okay. All right. So next thing I know, if it is E naught, I should have B naught, which is then equal to E naught divided by C. E naught divided by C is there here. It is there here. It is not there here. So this and this options goes out. Next thing, let's talk about electric field is in which direction? Y direction. So electric field cross magnetic field should be speed of light. Electric field is in j cap direction. Because it's kx minus omega t, x-axis is the direction in which the light is propagating. But is it negative x or positive x? If there is a minus sign here, it is going in positive x. If there is a plus sign, then it is going in negative sign. So negative means it is going in plus I cap direction. Okay. If this was kx plus omega t, then it would go in negative I cap direction. It's always opposite. If this is x, the wave is also going in x. If it's y, the wave is also going in y direction. Keep that in mind. So j into which vector will give you I vector? J into which vector will give you I vector? Yes, j cross k. So magnetic field should be in k cap direction, which is right over here. So that is D option. So this is also one common type of question where they give you electric field equation and they ask you what is magnetic field equation and all of that. Okay, moving on to the next one. Yeah, I was just talking about this refractive index and all of that. The speed of electromagnetic wave is how much if ER and mu R are relative permittivity and permeability. So speed in any medium is always root of permeability into permittivity. Now permeability and permittivity will be relative permeability into permeability of free space. And permittivity is permittivity relatively into permittivity of free space. So I can rearrange the terms, combine mu naught and epsilon naught together, and combine these two together. What is this quantity? That is the speed of light in vacuum, and what you are left out with relative permittivity into relative permeability. So that is the speed in that medium. In fact, if you divide C by V, you will get actually the refractive index also. So this is how you can get a refractive index also. So hence the answer is this. So the speed of light in that medium is speed of light in vacuum by the root of permittivity relative into permeability relative. Okay, standard thing. Right? Everybody with me? Very good, very good, very good. Let's go to the next question on your screen, and here it comes. If electric field amplitude is this much, its frequency is this much, then which of the following value is incorrectly computed? Angular frequency, propagation constant, wavelength, magnetic field amplitude. Wow, interesting question, guys. So let's find it out one by one. Electric field is given, so we can find magnetic field because E naught by B naught is C. So B naught will be E naught divided by C. E naught is 120. C is 3 into 10 to the power 8. So 12 by 3 is 4. And it will become 10 to the power minus 7. 0 and 0 will cancel. So 10 to the power minus 7. So B naught is 4 into 10 to the power minus 7, which is 400 into 10 to the power minus 9 Tesla. So this will become 400 nano Tesla. So A is obviously correct. A is obviously correct. Frequency is given. We can easily figure out the wavelength because C is F into lambda. Speed of light is 3 into 10 to the power 8. Frequency is 15 mega. So 10 to the power 6 into wavelength. So wavelength will be 3 by 5 and 10 to the power 8 by 10 to the power 7. 3 by 5 is 0.6. So into 10 will make it 6. Wavelength of the electromagnetic wave is 6 meters. So this is also going to be correct. Nothing wrong over there. Correct? Everyone till this point also clear? Okay. Then what else is there? We can find omega also. Omega is 2 pi f. So 2 pi multiplied by frequency, which is 50 megahertz. So 10 to the power 6. So 2 5s are 10. So 10 into 10 is 100 into 10 to the power 6. So this will become pi into 10 to the power 8 radian per second. Pi into 10 to the power 8 radian per second. So this is also correct. Propagation constant, angular wave number. I think then this is the only thing which will be wrong, because your k value, omega by k should be c. So omega by k should be c. Isn't that right? So omega by k is c. That means k will be nothing but omega by c. Omega is pi multiplied by 10 to the power 8. Speed of light is 3 into 10 to the power 8. So this should be pi by 3 radian per meter. So pi by 3, which will be 3.14 by 3, which will be 1 point something. So obviously C option seems to be incorrect. Yeah. So this kind of questions will eat away your time, but they will for sure give you the correct answer. Right? Awesome. Awesome. Moving on to the next question on your screen. The correct arrangement of increasing order of the wavelength, X-rays, UV rays, microwaves. Microwaves are in couple of millimeters to micrometers. UV rays are short wavelengths, they will be in nanometers. X-rays are in angstrom. Increasing order they have asked. So X-rays will come the first, the least, then will come UV rays, then will come microwaves. So X-rays, UV rays, and then microwaves, which is C option. You should know the approximate range of all these wavelengths so that it is easier for calculation or for elimination. Yeah. Chat is weird today. Why is chat weird, man? Yes, creative buddy. What was your doubt? Moving charges also required. Oh my god, so many things. Or mechanical properties of fluid. Guys, then you need to comment after the session. And I want a lot of likes on that comment also. Then I will do it. At least some 50, 100 likes will be there, then I'll get to know. But let's say again 10, 15 people will watch or 20 people will watch, then I will feel that I could have done a session which many people will benefit, because see, time is limited for me. Otherwise, I don't care about all these things. I will do everything because whatever is necessary. When time is limited, I have limited bandwidth. If I do something one day, then that's it. I will be missing out on one thing which I could have done. So, I need that uh, conviction from your side that yes, sir, we need this particular thing. And that conviction has to come very strongly, not very lightly, because very little time is there. I have only few classes left before your JEE Mains first attempt. Keep that in mind. Okay. So whatever you think wisely, which will actually truly benefit you. Okay. Yeah. All right. Okay, great. So where have we come? This was done. Yeah. Which of the following? Question number 69, guys. This is the last question coming up on your screen. Which of the following radiations of electromagnetic waves has the highest wavelength? Ultraviolet is in very small nanometers. This also is in nanometers. Microwaves in millimeters. X-rays is in angstroms. But out of ultraviolet and infrared, this nanometers is less than 400 nanometers. This is more than 700 nanometers. So which of them has the highest wavelength? Microwaves is in millimeters, so it has the biggest wavelength. Micro is more than nano, no? Anyways. Yeah, option C. Perfect. So match the following also can come. Sometimes increasing, decreasing order can come. Comparison can come. These are common questions over here. So that was your last question for today. Like this video, share this video, watch this video properly. PDF will be uploaded in the Ved support, yeah, of this session after a day. It will come up, and make sure you solve all the homework questions, ask with any doubts, and you will see it right over here in the description of this video. You will see it over here. Smart notes, quizzes. Ved access is free of cost for all of you, so make the full benefit of Ved right now before your JEE preparation. Else it was actually a subscription which was to be bought, but for every kid this year on Children's Day, we launched it as free for a limited time now. So make use of Ved. Yeah, all the best. Kudos. Take care. God bless you all. See you, in our next academic session in the new year. But yeah, I'm going to meet you in the next couple of days in different ways, but not for a marathon. All right. Take care. Bye bye. Captain Shreyas signing off.